In this section, you will learn about the different kinds of data you can work with in your Python programs. You will also learn how to use variables to represent data in your programs. So what really happens when you run main.py program? So let's take a closer look at what Python does when you run this program. And as you can see here, Python does a fair amount of work even when it runs a simple program, right? So when you run this code, you should see this following output here. So when you run this program, the ending PE here indicates that the file is a Python program. So your editor then runs the file through the Python interpreter, which reads through the program and determines what each word in the program means. For example, when the interpreter says the word print here, followed by the parentheses like this, it prints the screen whatever is inside in the parentheses. So as you write your programs, your editor highlights different parts of your program in different ways. For example, it recognizes the print is the name of a function and displays that word in one color. It recognizes that hello world Python or hello Typhoon is not a Python code, and it displays that phrase in a different color. As you can see in this case, it's green, and this is called the syntax highlighting. So here, for example, this is a green, right? So this is syntax highlighting. The Python tells us this is a string that's going to be print on the screen, and this is a function, built-in function that Python has, and these are the parentheses here. Let's see here. So whatever we write inside this parentheses will be printing here. And let's try using a variable with this print here. So now we will add a new line at the beginning of the file and modify the second line. So we will create a message or my super message here, and now let's make it this message hello Typhoon, welcome to this Python course. And here after that we will print this message. Oh, like this, print, and inside this we will enter our message, print my super message. And now let's run this program and let's see what happens. By the way, you can run this program with Shift and F10, this combination of shortcut, and you can also run this by pressing this run main button here. And so we added variable named message here, this message here. Every variable is connected to a value, right, which is the information associated with that variable. In this case, this variable here, let me actually get my pen. Yes, so this variable here is connected. So this is the value. So this value here is connected to my super message named variable. So adding a variable makes a little more work for Python interpreter when it processes the first line. So this is the first line. Firstly, it associates this variable my super message with the hello Typhoon, welcome to the Python course value. So when it reaches the second line, it prints the value associated with my super message, in this case it's welcome, oh hello Typhoon, welcome to this Python course here, right? And let's expand on this program by modifying this main PE to print a second message. Now let's add a blank line here and then add 2 new lines of code. So here we will again write my super message, and this is the best and fastest Python course in the world. And that's it. Now we will again print the message, which is my super message. Now here, let's run this and you will see what happens now. So you can change the value of variable in your program at any time, and Python will always keep track of its current value. So for example, when we first defined my super message, its value was this. Hello Typhon, welcome to this Python course, and this is the print that we printed here. And the second variable, this is the same variable, right? These are the same. These are the same for now. These are the same variables, but they for after line 4, they do not contain the same values. That's it. You can change variables whenever you want in Python. And here, now let's learn about the naming and using our variables, which is you will need in Python a lot of times. So I'm waiting you in the next lecture. When you're using variables in Python, you need to adhere to a few rules and guidelines. Breaking some of these rules will cause errors. Other guidelines just help you write code that's easier to read and understand. And be sure to keep the rules in mind when working with variables. So first, let's start with variable names. So variable names can contain only letters, numbers, and underscores. They can start with a letter or an underscore, but not with a number here. For instance, you can call variable message underscore 1. So you can define variables like this, but you cannot define 1 underscore message, but not like this. And this is a mistake because you cannot define a variable that starts with a number, right? So this is a mistake. And you cannot define variable with spaces here. So avoid, and also avoid using Python keywords and function names as variable names. For example, do not use word as print as a variable name. So Python has reserved it for a particular programmatic purpose. And variable names should be short but descriptive. For example, name is better than n, or student name is better than sn, right? So, and so the name length here is better than length of person's name, right? So be careful when using the lowercase letters and uppercase letter, the lowercase letter L and uppercase letter O here, because they could be confused with the numbers 1 and 0. And it can take some practice to learn how to create a good variable names, especially as your programs become more interesting and complicated. As you write more programs and start to read through the other people's code, you will get better at coming up with meaningful names. So, and avoid name errors when using variables as well. So every programmer makes some mistakes, and most make mistakes every day. Although good programmers might create errors, and they also know how to respond to those errors efficiently. So let's look at an error you are likely to make early on and learn how to fix it. So here we will write some code that generates an error on purpose. So now we'll write this following message. So message, my super mega message, and message here, and we will make this message, for example, hello every student from your instructor Typhon here. And here we will print this message, print my super mega message. So when, let's run this here. This is, so when an error occurs in your program, the Python interpreter does its best to help you figure out where the problem is. The interpreter provides a traceback when a program cannot run successfully. So a traceback is a record of where the interpreter ran into trouble when trying to execute your code. Now we will write this. For example, this code is successfully interpreted here and run. And let's delete this S from the one S from the message, and let's run it. And as you can see here, this is our traceback. This is an example of traceback that Python provides after you accidentally misspelled a variable's name. So here we will need an S here, right? So and as you can see here, the name my super mega message is not defined here, and we have an error in line 2. And the output reports that an error occurs in line 2 of the file of main.py. So the interpreter shows this line to help us spot the error quickly and tells us what kind of error it found. And in this case, it found a name error, and here name error, and reports that the variable being printed message has not been defined. That's because we entered the wrong value in it. And in a name error usually means we either forgot to set a variable's value before using it, or we made the spelling mistake when entering the variable's name, as we did here. And if the Python finds a variable name that's similar to that one, it doesn't recognize, it will ask if that's the name you meant to use. So in this example, we omitted the letter S in the variable name my super mega message in the second line. So the Python interpreter doesn't spell check your code, but it does ensure that the variable names are spelled consistently. For example, watch what happens when we spell message incorrectly in the line that defines the message here. So let's make it again, and as you can see here, our code is run successfully. So in this case, the program runs successfully, right? So the variable names match. So Python sees no UGM. So as a result, and programming languages are strict, but they disregard good and bad spelling. So as a result, you don't need to consider English spelling and grammar rules when you're trying to create variable names and writing code. So many programming errors are simple, single character typos in one line of program. If you find yourself spending a long time searching for one of these errors, know that you are in a good company. And many experienced and talented programmers spend hours hunting down these kinds of tiny errors and try to laugh about it and move on. So knowing it will happen frequently throughout your programming life. And we also need to know about variables. So variables are labels. So variables are often described as boxes like this that you can store values in it. So for example, let's name it the variable. Oh, sorry, let's actually get the pen. So let's make it variable, and we have the value. So the idea can be helpful. This idea can be helpful the first few times you use a variable, but it isn't an accurate way to describe how variables are represented internally in Python. So it's much better to think of variables as labels that you can assign to values. You can also say that a variable references a certain value. So this distinction probably won't matter much in your initial programs, but it's worth learning earlier rather than later. At some point, you will see unexpected behavior from a variable, and an accurate understanding of how variables work will help you identify what's happening in your code. And the best way to understand new programming concepts is to try using them in your program. So if you get stuck while working on exercise in this course, try doing something else for a while. So if you are still stuck, review the relevant part of that section and watch this lecture again. If you still need help, you can ask me anytime and I will answer you immediately. Note that this assignment sign in the statement, for example, user age equals 19, has a different meaning from the sign we learned in math. So in programming, this assignment sign is known as an assignment sign. Actually, in the program is equal sign. So it means we are assigning the value on the right side of the sign. This is the value that we are assigning to this variable in the left side. A good way to understand the statement user age equals 19 is to think of the user age this, right? So this statement, A equals B and B equals A has a very different meanings in programming. Confused? An example will clear this up. So let's type this following here. X equals, or A equals 5, B equals 10, and A equals B here, right? So now we will print this here, print our A equals to A, and print again our B equals to B, right? And now let's run the program. And as you can see here, A equals to 10, B equals to 10. So now, although A has an initial value of 5, you can see here, declared on the first line, and the third line, A equals B, assigns the value of the B to A here. So we are assigning, with this code, we are assigning a value of B to A. And now we are assigning, in the first line, we are assigning 5 to A, and after that, we are assigning 10 to B. So here are A equals to 5, and now B, we don't have B here, so we don't have B here, and here B, A equals to 5, B equals to 10, and here our A equals to 10 and B equals to 10 here. And next we can modify this by changing only one statement. So let's change the third line from A equals B to B equals A. Now let's run this program again, and as you can see, we have A equals 5 and B equals 5. And here mathematically, the A equals B and B equals A mean the same thing. However, this is not so in programming. And now let's run this program again, and as you can see, we got this A equals 5, B equals 5. So you can see that in this example, the A value remains as 5, but the value of B is changed to 5 from 10. So this is because the statement is in the third line, B equals A, assigns the value of A to B, and B becomes 5, while A remains unchanged as 5. Because most programs define and gather some sort of data and then do something useful with it, it helps to classify different types of data. The first data type we'll look at is strings. Strings are quite simple at first glance, but you can use them in many different ways. The string is a series of characters. Anything inside quotes here is considered a string in Python. You can use a single or double quotes around your strings like this. So this is the flexibility allows you to quotes and apostrophes within your strings. So let's explore some of the ways you can use with strings. We can also change the case in a string with methods. So one of the simplest tasks you can do with a string is change the case of the word in a string. Let's look at this following code. Let's here name this is the world's best Python course here, and here we will print is our name, right? Name dot title, and let's make it this here. That's it. Now let's run this here with Shift and F10 shortcut, or you can press on this button as well. And as you can see here, this is the world's best Python course, right? In this example, the variable name refers to the lowercase string. This is the world's best Python course, and the method title here appears after the variable in the print call. A method is an action that Python can perform on a piece of data. The dot here, this dot here, so you can, oh sorry, that's actually, yes, this dot here, after name, in name.title tells Python to make the title method act on a variable name. So we will act this title method on a variable name. So now every method is followed by a set of parentheses because methods often need additional information to do their work. This is the first parenthesis. For now it's empty, but the print method has something to show us, right? And that's why we have this parenthesis here. And here the title function for now doesn't need any additional information, so these parentheses are empty. And the title method changed each word to title case, where each word begins with the capital letter. In this case, the T here, and this is the world's best Python course. So each changed all the words that starts with a capital letter. And that's what title does here. So this is useful because you will often want to think of a name as a piece of information. For example, you might want to program to recognize the input values of this here. For example, this or this or this and or this, right? So you might want to program to recognize these outputs as the same name and display all of them as this, right? So several other useful methods are available for dealing with case as well. For example, you can change a string to all uppercase or all lowercase letters like this here. Let's change this. Oops, actually let's delete this useless information here. And now we will use the name.upper, which is gonna, as you can see here, this give us output with all uppercase characters. And we can also use the lower, and as you can see here, this is the all lowercase, and actually it didn't do anything in particularly, but because our name variable, our name value was the all lowercase. So if you do like this, oops, sorry, let's make it the uppercase as uppercase here. And as you can see here, now we are seeing something that has changed. And the lower method is particularly useful for storing data. So you typically won't want to trust the capitalization that your users provide. So you will convert strings to lowercase before storing them. So then when you want to display the information, you will use the case that makes most sense for each string. You can also use variables in strings, which you will learn in next lecture. In some situations, you will want to use a variable's value inside a string. For example, you might want to use two variables to represent a car's model and make, and respectively, and then combine those values to display some car's full model, right? So now we will make this car here, car make, and in this case let's actually make it BMW, and now car model, and here we will make it 500 series, 5R series, and let's actually make the year, right? 2014. And now we will make it car here. We will make it F. This is the format. And car make. Oops, sorry. First the car make. And after that, we will enter the car model. Car model, right? And as you can see, that's it. Now we will print this. Print car. Let's print this. And as you can see here, BMW 5R 2014. And to insert the variable's value into string, place a letter F. Place a letter F immediately before the opening quotation mark here. That's what we did here, right? We placed the letter F, and after that put the braces around the name or names of any variable you want to use inside a string, and Python will replace each variable within its value when its string is displayed. In this case, it's, as you can see, inside braces we have car model, we have space here, this is a space here, and that we also have space here. Oops, not here, here. And we also have car model, which is our car model was 5 Air 2014, and this is it, right? And these strings are called, so these are these strings here, these strings are called the F strings here. F strings. These strings are called F strings. So this F here means format. Format, because Python formats the strings by replacing the name of any variable in braces with its value. So the output of this code will be this here. You can change these variables and values as well here. So you can do a lot with F strings. For example, you can use F strings to compose complete message using information associated with a variable, as like this. For example, we have a car, right? So we can also do this, right? So my message here, it's gonna be F Typhoon drives a car, and that's it. Now let's let's use this uppercase, and as you can see here, oops, we have to change the car, so to my message, and here Typhoon drives a BMW 5 Air 2014. So that's a full name. This is the full message is used in a sentence that reads that sends the user that what Typhoon drives, and we have the variables that used with the F strings. You can also use F strings to compose a message and then assign the entire message to variable, as we did here. And now we will here, let's actually do another here. And here we have my message Typhoon, here my bigger message here, and we will do again. So F here, my message, firstly my message, and he crashed it. And here we will do print again my bigger message here, and as you can see, Typhoon drives a BMW 5 Air 2014 and he crashed it. In programming, a white space refers to any non-printing characters, such as spaces, tabs, and end-of-line symbols. You can use white space to organize your output so it's easier for users to read. Now let's add a tab to your text. So you can use this character combination to add tab to your text. So now let's print here, this here. This is a Python tab, and after that we will add this character combination, or actually let's add this between this is M and Python tab T here. Now let's run it, and as you can see here, we have a tab here. This is a tab. So to add a new line in a string, you can use the character combination of N here. And as you can see here, this is a new line. This is a new line, and after that we have another space character that we used here. So let's delete this and this. Here you are seeing the new line without any spaces here. But we can also do like this, for example, print programming languages and languages, and here we're gonna add the new line and Python, or we can also before programming languages, let's add character tab so it will look nice. So Python, C++, or yes, new line C++, new line Java, new line Swift. And here, as you can see here, we have a tab here, Python, C++, Java, and Swift with new lines here. So you can also combine the tabs and new lines in a single string, and the strings nt here, nt, tells Python to move to a new line and start the next line with tab. Now we will do that here. Let's actually add two tabs here. You can add here. And as you can see here, there are programming languages, Python and C++ with two tabs here. This is the first tab and second tab, first tab and second tab. And here we have Java with only one tab and Swift with only one tab here. And as you can see, it's here, new line tab, new line tab, and new line tab, tab here, and new line tab, tab. So new lines and tabs will be very useful in the next two sections when you start to produce many lines of output from just a few lines of code. Extra white space can be confusing in your programs. To programmers, Python here, Python, and this Python here looks pretty much the same when you print it, right? But to a program, they are two different things. Python detects the extra space in this second Python here and considers it significant unless you tell it otherwise. So it's important to think about white spaces because often you will want to compare two strings to determine whether they are the same or not. For example, one important instance might involve checking people's usernames when they log into a website. Extra white space can be confusing in much simpler situations as well. Fortunately, Python makes it easy to eliminate extra white space from the data that people enter. So Python can look for extra white space on the right and left side of a string. To ensure that no white space exists at the right side of a string, you can use the rstrip method. So here, let's actually my best language or my best coding language here. So here we will have the Python here. So Python, but with white space here, as you can see. And secondly, we will use the my favorite, or let's actually print it firstly, my best coding language. And as you can see, it's Python here, and we have a one white space here, obviously. Now we will do my best coding language.rstrip. That's it. And here we will print this my best coding language again. And here you will see nothing. As you can see here, they are the same. So in order to do that, here we will use with here. So this is just a temporary. We will use the permanent method as well. But for now, we're gonna use temporary here, rstrip, and here we will do. That's it. And here, as you can see, we have no white spaces here. We have no white spaces here, but here we have one white space, right? This is the white space here. So with rstrip, we remove the extra white space on the right side of a string. The value associated with my best coding language contains extra white space at the end of the string, as you can see here. So when you ask Python for this value in terminal session, you can see the space at the end of the value. When the rstrip methods acts on the variable my best coding language, this extra space is removed. However, as I said, it is only removed temporarily. So after that, it would do like print the my best coding language again. It will still print us with the white space here. So this here, this is the third here, second here, oops, second here, and this is the first Python print here. So as I said, it's only removed temporarily here. This is with the white space again, as you can see here. So if you ask for the value of my best coding language again, the string looks the same as when it was entered, including the extra white space. To remove the white space from the string permanently, you have to associate the stripped value with the variable name. In order to do that, we're going to do my best coding language equals my best coding language dot rstrip. Now we will see this here. As you can, this is the with white space and without white space. Let's print this more than one time to see here, and as you can see here, we will get the same result, of course. So this is the without the white space, with the white space, and all of these are without the white space. So that's it. To remove the white space from the string, you strip the white space from the right side of the string, and then associate this new value here, this new value with this here, because rstrip here we have, and we are associating this my best coding language with stripped version to normal version here. So in this example, we start with the, so let's actually use this, add this here, and you will see this, and as you can see, we all have the here. Now we're gonna do another example. So firstly, we will define this my best coding language with the two white spaces on the both sides, and after that we want my best coding language dot rstrip, and here we will print it, of course. Firstly, print my best coding language dot rstrip, and here, as you can see here, we printed with the right strip here. So now we're gonna do as well as left strip, L strip, and here, as you can see in the first example, we have no right white space, but we have a left white space. But here we have no left space, but we have in a right side we have a white space. So in order to do that, we will firstly associate my best coding language that equals the my best coding language dot L strip here, and after that we will my best coding language dot rstrip, and after that we will print the value. So as you remember, this is a permanent solution here, and as you can see here, we have no right spaces or left spaces on the both sides. So when working with strings, another common task is to remove a prefix. Consider a URL with the common prefix of HTTPS. Here we want to remove this prefix so we can focus on just the part of the URL that the user needs to enter into an address bar. Here's how you do that. So Udemy URL here, Udemy URL, and here we will enter the Udemy URL here, HTTPS and udemy.com, and here they will use the Udemy URL dot remove prefix, and here we will enter HTTPS here. Now we will print the Udemy URL, or actually let's print this here, print here, and here let's see, as you can see here, we removed the HTTPS from the Udemy. So enter the name of the variable followed by a dot here, and then the method is remove prefix. Inside the parentheses, you enter the prefix you want to remove from the original string, like we did here. So like the methods from the removing white space, remove prefix leaves the original string unchanged. So if you want to keep the new value with the previous prefix removed, either assign it to the original variable or assign it to a new variable. So now we will use this. So my Udemy URL without prefix, and here we will enter this Udemy URL dot remove prefix and HTTPS here, and here we will enter the print and Udemy URL without prefix here, and as you can see, we removed Udemy URL that had HTTPS prefix before it, and we printed it, so we have that variable permanently. But whenever we try to print this Udemy URL, it will show us the same because we didn't change this Udemy URL. We created new variable here. This is the new variable, and we took that. So we removed the prefix. So this has the udemy.com, but in the first variable we have we have the https udemy.com. So these are two separate variables. Don't confuse here. These are two separate variables. They don't have the associations. And only association this variable has is that it only took this from the variable. So, but they are separate variables and they are can be manipulated separately. One kind of error that you might see with some regularity is syntax error. A syntax error occurs when Python doesn't recognize a section of your program as a valid Python code. For example, if you use an apostrophe within a single quote, you'll produce an error. This happens because Python interprets everything between the first single quote as the apostrophe and the apostrophe as a string. It then tries to interpret the rest of the text as Python code, which causes error. So here's how a single use of double quotes correctly. Now we will use, for example, my special message, and here we will use this is the fastest and best Python course in the world. So this is the fastest in, or actually let's make the Pythons here. Yes, it might sound grammatically incorrect, but it is just a code and example. So Python's course. Now let's print this message. Print my special message, and as you can see here, we have no error even we have a single quotes here. So the apostrophe appears inside a set of double quotes, so that let's actually make this like that. So here we are, we're gonna see this here. As you can see here, this is fastest. This is the error, this is the invalid syntax. In order to do that here, you have this backslash here, and it will fix the code. And if the same applies for the single quotes as well, let's actually add our single quotes. As you can see here, we have a code without a problem. And if we add this here, Pythons, and we are seeing error again. So in the output, you can see that error occurs right after the final single quote here. So this syntax error indicates that the interpreter doesn't recognize something in the code as a valid Python code, and it thinks the problem might be a string that's not quoted correctly. Error can came from a variety of sources, and I will point out some common ones as they arise. So you might want to see syntax errors often as you learn to write proper Python code. So syntax errors are also the least specific kind of error, so they can be difficult and frustrating to identify and correct. So if you get stuck on a particular stubborn error, you can ask me and I will answer you immediately. Numbers are used quite often in programming to keep score in games, represent data in visualizations, store information in web applications, and so on. Python treats numbers in several different ways, depending on how they are being used. So let's first look at how Python manages integers, because they are simplest to work with. So you can add, subtract, multiply, and divide integers in Python. Let's do this following example. My value here, 2 plus 10 here, and let's print this value, my value. And here you can see here 2 plus 10 is equal to 12, or let's actually 9 subtract here 99 here, and as you can see here, my negative 9 negative 90, and let's multiply it. For example, 5 multiply 5 by 10. Oops, multiply 5 by 10, and here we have 50. And let's actually divide 5 by 10 and 0.5. So in a terminal session, you can also Python simply returns the result of the operation. And here Python uses two multiplication symbols to represent exponents like this. For example, 5 exponent 10 is equals to this here. For example, 3 exponent 3 equals 27, and 10 exponent 6 equals 1 here, 1 2 3 1 million here. So Python supports the order of operations too, so you can use multiple operations in one expression. You can also use parentheses to modify the order of operations, so Python can evaluate your expression in the order you specify. For example, this. So my value here, 2 plus 3 and multiply by 4 or 5. And here you can see the first 5 multiplied by 5 here. So the spacing in these examples has no effect. How Python evaluates the expression, it simply helps you more quickly spot operations that have priority when you are reading through the code. And we also have floats in Python. So Python calls any number with a decimal point. Python calls any number with a decimal point is a float. For example, this 1.478 is float. So this terminology is used in the. Let me actually firstly fix this here, because our marker menu should be here somewhere. Yes. So the term is used in most programming languages, and it refers to the fact that a decimal point can appear at any position in a number. So every programming language must be carefully designed to properly manage decimal numbers, so numbers behave appropriately, no matter where the decimal point appears. For most part, you can use floats without worrying about how they behave. Simply enter the numbers you want to use, and Python will most likely do what you expect. For example, 0.2 plus 0.9, and here 1.1, and here, for example, 2 multiplication 0.2, and here, oops, sorry, yes, 0.4, and here we have the run it again, yes, 0.4, and here we have 2 multiplication by, for example, 99 here with some this, and here you can see we multiply this number with 2. So this happens in all languages, and let's actually, there's some bug here. Not bug, but you should see it. So here we have 3 multiplied by 0.1, and this here. So and this is a little concern, right? This happens in all languages here, in C++, in Java, and so on. So Python tries to find a way to represent the result as precisely as possible, which is sometimes difficult given how computers have to represent numbers internally. Just ignore the extra decimal places for now, and you will learn ways to deal with this extra spaces here. Just here, ignore this here for now. So when you divide any number, when you divide any two numbers, even if they are integers, that result in a whole number, and you will always get a float in mathematically, right? So let's do this. For example, 4 here, 2, and we got 2.0 here. So if you mix any integer and float in any other operations, you will get a float as well. Like, for example, 1 plus 2.0, and we got 3.0. Let's actually use 2 multiplied by 9.0. We got 18.0. And if we this same applies for the multiplication here, exponents. So 3 exponent 2.0, we are seeing here 9.0. So Python defaults to a float in any operation that uses a float. So even if the output is a whole number. When you are writing long numbers, you can group digits using underscores to make large numbers more readable. For example, this. The students. And here we will use this students variable as a count of students. For example, let's make it for 50 million, right? So when you print the number, students, print students, here So when you print a number that was defined using underscores, Python only prints the digits. So Python ignores the underscores when storing these kinds of values, even if they don't group the digits in trees. And the value here, let's actually, the value here will be still affected. So for Python, the 1000 like underscore after 1 is the same as underscore after 10. So this feature works for both integer and floats. And we also have multiple assignment here feature in Python. So you can assign values to more than one variable using just a single line of code. So this helps you shorten your programs and make them easier to read. And you will use this technique most often when initializing a set of numbers. For example, here's how you can initialize the variables a, b, c to 0 here. A, b, c, and here 0, 0, 0. 0, 0, 0. So you need to separate the variable names with commas here and do the same with the values. So, and Python will assign each value to its respective variable. As long as the number of value matches the number of variables, Python will match them up correctly. So let's print this here. Print a here, a equals to a, and print b equals b. Let's print the b. Print here and c. Now we will here, and as you can see here, a equals to 0, b equals to 0, and c equals to 0. If we delete this, we will get an here error because non-iterable ink project. So if you do like this, for example, a equals to 0, b equals to 98, c equals to, for example, 55. And here, as you can see here, we assign them accordingly. And we also have constants in Python. So a constant is a variable whose value stays same through the life of a program. So Python doesn't have built-in constant types, but Python programmers use all capital letters to indicate a variable should be treated as a constant and never be changed. So for example, one of the constants might be, for example, maximum number of, for example, maximum value here, or maximum customers, for example, and in this case, let's make my maximum customers 500. So when you want to treat a variable as a constant in your code, write the name of variable in all capital letters. And we also have comments in Python. So comments are extremely useful feature in most programming languages. Everything you have written in your programs so far in Python code. So as your programs become longer and more complicated, you should add notes with your programs that describe your overall approach to the problem when you're solving. So a comment allows you to write notes in your spoken language within your programs. So how do you write comments? In Python, the hash mark, this hash mark, oops, sorry, fix that. So in Python, this hash mark indicates a comment. Anything following this hash mark here in your code ignored by the Python interpreter here. So for example, let's say this, right? Oops, here. Hello everyone. This is a comment and I'm explaining something about my code. So here, after that, we will print, for example, print hello my students here. Students. Now we will print this, and as you can see here, Python ignores the 5th line here and executes the 2nd line. what kinds of comments you should write. So the main reason to write comments is to explain what your code is supposed to do and what you are making it work. So when you are in the middle of working on a project, you understand how all of the pieces fit together, but when you return to a project after some time away, you will likely have forgotten some of the details. So you can always study your code for a while and figure out how segments are supposed to work, but writing a good comments can save you time by summarizing your overall approach clearly. So if you want to become a professional programmer or collaborate with other programmers, you should write meaningful comments. Today, most software is written collaboratively, whether by a group of employees at one company or a group of people working together on an open source project. Skilled programmers expect to see comments in code, so it's best to start adding descriptive comments to your programs now. So writing clear, concise comments in your code is one of the most beneficial habits you can form as a new programmer. So when you're deciding whether to write a comment, ask yourself if you had to consider several approaches before coming up with a reasonable way to make something work. So if so, write comment about your solution. It's much easier to delete extra comments rather than go to back and write comments for sparsely commented program. For now, I will use comments in examples through this course to help explain sections and codes of this course here. In the section and next, you will learn what lists are and how to start working with the elements in a list. Lists allow you to store sets of information in one place, whether you have just a few items or millions of items. Lists are one of the Python's most powerful features, readily accessible to new programmers, and they tie together many important concepts in programming. What is a list? A list is a collection of items in particular order, and you can make a list that includes the letters of the alphabet, the digits from 0 to 9, the names of all the people in your family. You can put anything you want into list. And the items in your list don't have to be related in any particular order or way. So because a list usually contains more than one element, it's a good idea to make the name of your list plural, such as instead of my special, you can write my special numbers like this, or letters, digits, or names. So in Python, these square braces indicate a list, and individual elements in the list are separated by commas here. And let's create a simple example of a list that contains a few kinds of car models or car makes. So car makes here, and here we will enter, for example, Mercedes, Mercedes here, as Benz here, and we will enter the BMW, and we will enter Volkswagen, Honda, Kia here, Hyundai here, and so on. So here we will print this car makes here. And as you can see here, we have Mercedes-Benz, BMW, Volkswagen, Honda, Kia, and Hyundai. So if you ask Python to print a list, Python returns this representation of the list, including the square braces here. So because this isn't the output you want your users to see, let's learn how to access the individual items in a list. Lists, and this is why we draw this drawing here, and we will explain on this list here. So we first created my special numbers here, as you can see here. So this associated with this here. Now let's get here. That's it. So lists are ordered collections, so you can access any elements in a list by telling the position or index of the item desired. So to access an element in a list, write the name of the list followed by the index of the item enclosed in square braces. So now let's try with my special numbers here. So if we want to write my special numbers here, we will delete this. Let's actually delete this, my car names, and now we will enter the print my special numbers. Let's print a number 65. In order to print a 65 here, we will enter the index of the 65, 3. So remember, index starts from 0 here. And here, as you can see here, we printed 65. So that's the answer you will get here. So this is the result you want your users to see. Clean, neatly formatted output. So you can also use the strings methods in this. Let's actually delete this here. And let's make the car makes the car makes dot. You can also use string method. For example, car makes dot. We will use the uppercase. Car makes dot. First we will enter the, for example, 1, index 1, and upper here. Now you will see this. As you can see, BMW started with uppercase, but BMW was uppercase actually. So instead of this, let's try with Hyundai here. So 0 here, let's count this. So this is 0, 0, BMW 1, index Volkswagen 2, index of Honda is 3, index of Kia is 4, and Hyundai is 5. That's it. So we will enter the 5 here inside the square braces, and now let's run it. And as you can see here, we've written it Hyundai in uppercases, and this example produces the this output here. So we can and keep in mind that index positions start at 0 and not 1. So I want to write this here because I want to. The new programmers can sometimes be mistaken about the index position starting point here. So index oops, actually let's write with text here. So index positions start at 0 and not 1. That's it. Keep in mind this word here. Index positions start at 0 and not 1. That's it. Here. Now, a Python considers the first item in a list to be put at a position of 0 and not position 1. So this is true for most programming languages, and the reason has to do with how the list operations are implemented at lower level. So if you're receiving unexpected results, ask yourself if you are making a simple but common off by 1 error. So the second item in the list has an index of 1, right? Index of 1. And using this counting system, you can get any element you want from a list by subtracting 1 from its position in the list. So for instance, to access the fourth item in the list, you request the item or index at 0, right? 1, 3. So if you are, so the Honda is actually the fourth item in this list, but in order to access them, we will use 3 here. So now we will, let's run this again, and here, and as you can see, we got Honda here. So Python has a special syntax for accessing the last element in a list. If you ask for the item at index -1, Python always returns the last item in the list. So here, and as you can see here, Hyundai was the last item in our list. So here, let's actually do this. -1 returns -1 always returns the last item in the list here. Also keep in mind this. So that's it. Oops, sorry, not like this. -1 always returns the last item in the list. That's it. So this code here, as you can see, it returned Hyundai, and this syntax is quite useful because you will often want to access the last items in a list without knowing exactly how long the list is. So this convention extends to other negative index values as well. For example, -2 returns the second item from the end of the list, and -3 returns the third item in the end of the list, and so forth. So you can also use the individual values from a list. So you can use individual values from a list just as you would any other variable. For example, you can use f strings to create a message based on a value from a list. So let's try pulling the first our car model from the list and composing a message that uses that value. So now here we will do this. Print. Let's make the we will use the f here, and now my first car was let's say BMW here, and we will use this braces, but BMW, so car makes that 1, because the BMW index has 1, and we will use this, for example, title, right? And here my first car was a BMW. The syntax for modifying an element is similar to the syntax for accessing an element in a list. To change an element, you can use the name of the list followed by the index of the element you want to change, and then provide a new value you want that item to have. For example, let's say we have a list of car makers, and the first item in the list is BMW, right? So let's make the car makers here, and we will create the 5 or 3 items here, so it will easy to print on the screen. So Honda or BMW here firstly, and then Honda, and then for example like Kia, right? Or Ford. Yes, Ford. That's it. And here we will print the car makers. That's it. And as BMW, Honda, Ford, there is nothing weird in here, right? We didn't change anything or manipulate anything. Now we will write, for example, this car makers from index 0. We will change BMW to Jeep or Dodge here. And as you can see here, we will firstly write print this, and as you can see here, we changed BMW to Dodge, and our new list of car makers doesn't have the BMW inside it. So here we define the list of car makers with BMW as the first element, and then we change the value of the first item to Dodge. And the output shows that the first item has been changed while the rest of the list stays the same. You can change the value of any item in a list, not just the first item. Just remember here. So let's do the same to here. And as you can see here, we changed Ford here to Dodge. And you can also add an element to a list, and you might want to add a new element to a list for many reasons, right? For example, you might want to make a new car makers, add a new data to visualizations, or add a new registered users to a website you build. So Python provides several ways to add a new data to existing lists, and the simplest way to add a new element to a list is to append the item to the list. So when you append an item to a list, the new element is added at the end of the list, and using the same list we had in a previous example, we will add the new element. We will add a new element, for example, Jeep, to our end of the list. So car makers dot append Jeep here, and after that we will print the car makers, and that's it. And here, as you can see here, we added Jeep here. So here we append methods adds Jeep to the end of the list without affecting any other elements in the list. And the append method makes it easy to build the list dynamically. For example, you can start with an empty list and then add items to the list using a series of append calls. Let's do this here. For example, car makers, and here we will create the empty list here, and car makers that append BMW,
BMW carmakers.append Honda here. Here let's append Jeep here. Oops, append Jeep. And here we will also append the Ford. That's it. Also, of course, we need to print it to show you. And that's it. We created list from 0. And this resulting will look exactly the same as the list in the previous examples, but we changed a little bit here because, as you remember, the Jeep was at the last and Ford was firstly here. That's okay. Here, a building list this way is very common because you often won't know the data your users want to store in a program until after the program is running. So to put users in control, start defining an empty list that will hold the user's values, and then append each new value provided to the list you just created. Now you can also insert an element to the list. So you can add a new element at any position in your list by using the insert method. So you can do this by specifying the index of the new element and the value of the new item. So we'll create a car makers to don't confuse you, and car makers, and we will make it the BMW, or let's start with Honda. It doesn't make any difference for now because it's variable. So BMW, Honda, and let's make it the Volkswagen, and Jeep here. Let's Fiat here, and Opel here, Saab. That's it. That's okay. That's enough here. So you can add a new element to any position in your list, as I said, by using the insert method. So you do this by specifying the index of the new element and the value of the new item. So for example, car makers here, carmakers.insert. So here we will insert 0. So let's find the new Mercedes here, right? Or let's use some Japanese cars, in this case Lexus, and here we will print the car makers now. And here, as you can see, we changed the Honda to Lexus, but instead, you remember, here we didn't change the Honda here. Honda is still appears here, but we added Lexus here. So instead of 1 2 3 4 5 6 7 items, here we have 1 2 3 4 5 6 7 8 items. So we added Lexus at the start of the list. So in this example, we insert the Lexus at the beginning of the list, and the insert method opens a page at position 0 and stores the value the Lexus at that location. So this operation shifts every other value in the list by one position to the right. Here, sorry, let's get this pen. So here BMW was 3 here. Oops, let's actually get my pen here and make it proper color. Yes. So Honda was 0, BMW was 1, Volkswagen 2, Jeep 3, Fiat 4, Opel 5, and Saab was 6 item in that has 6 index of the list. And here since we added Lexus here, Lexus now is 0, Honda is 1, BMW is 2, Volkswagen is 3, Jeep is 4, Fiat is 5, and Opel is 6. Lastly, that's because we added one item at the start of the list here, and we have the 7 on the sub. So as I said, the this operation shifts every other value in the list one position to the right. We can also remove an element from a list. So often you will want to remove an item or set of items from a list. For example, when a player shoots down an alien from the sky, you will most likely want to remove it from the list of active aliens, or when a user decides to cancel their account on a web application you created, and you will want to remove that user from the list of active users. So you can remove an item according to its position in the list or according to its value. Now, if you know the position of the item you want to remove from a list, you can use del statement like this. So we will first print the car makers to make sure what we changed in this list, and we will del here car makers 0. That's it. And after that we will print our car makers. Print car makers. And as you can see here we use the del statement to remove the first item, which is BMW, from the list of car makers. So you can remove an item from any position in a list using the del statement if you know its index. For example, here's how to remove a second item. BMW, or yes, here we remove the Honda here, but in this case we will remove the let's remove the third item. In this case we will enter the Q, and as you can see here we removed the Volkswagen. So now the third item is deleted from the list. In both examples you can no longer access the value that was removed from the list after the del statement is used. Sometimes you will want to use the value of an item after removing it from a list. For example, you might want to get the A and B position of an alien that was just shot down, so you can draw an explosion at that position and so on. So in a web application you might want to remove a user from a list of active members and then add that user to a list of inactive members. So the pop method removes the last item in a list, but it lets you work with the item after removing it. The term pop comes from the thinking of the list as a stack of items and popping one item off the top of the stack. So in this analogy, the top of stack corresponds to the end of the list. So let's pop sap from the list of car makers. Now we will make this, for example, this, right? So popped car, and here we will enter the car makers dot pop here. That's it. And after that we will print the popped firstly car makers, and after that we will print the popped car. That's it. And here we start by defining and printing the our car makers, and then we pop a value from the list with this here, as you can see here. So let me actually adjust my mouse speed. So now I will explain all of this now. So firstly, we define the list of the car models here, car makers, and then we print it. So after that we pop a value from the list and assign that value to popped car. In this case, our popped car is equals to sap here because we popped sap here and nothing else. And after that, we are printing our car makers, which is here at the second here. And as you can see here, we don't have sap here. And after that, we are printing our popped car here, which is here. Sap. That's it. So then we print the popped value, and to prove that we still have access to that value that was removed. So the output shows that the value sap was removed from the end of the list and is now assigned to a variable named popped car. And remember, this is not a list, this is just a variable, this regular string variable. So how might this pop method be useful? So imagine that the car makers in the list are stored in chronological order according to when we own them, right? If this is the case, we can use the pop method to print a statement about the last car model we bought, car maker we bought, right? So we can also use this. Now we will, since we pop the car, now we will print the car maker. After that we will print the popped car, and we will add another print, which we will use the format, right, as we used in previous year. The last car maker or car model that Typhoon owned is a or was a and last, so here popped car, or actually let's change this here to last owned car here, and pop last owned car. That's it. The output is simple sentence about the recent and last owned car model we had here. In this case it was Saab. You can use pop to remove an item from any position in a list by including the index of the item you want to remove inside the parentheses. So for example, let's make this here. So this is the 0 and we will change it to first owned. So here first owned car, and here first owned car. And remember, the firstly here our first owned car variable was Saab, right? It's because of this, when we use the pop method without any parameters inside this, we will get the last item. And here we will enter the 0 index here, and as you can see here, we got Honda here. So remember that each time you use pop, the item you work with is no longer stored in the list. So if you're unsure whether to use the del statement or pop method, here's a simple way to decide. So when you want to delete an item from a list and not use that item in any way, you can use the del statement. So, but if you want to use an item as you remove it, you can use the pop method. You can also remove an item by a value. So sometimes you want to know the position of the value you want to remove from a list. So if you only know the value of item you want to remove, you can use remove method like this. Remove. So here, for example, say we want to remove the BMW from the list of car makers. We will do this BMW here. That's it. And now we will enter here, and as you can see, none here, but here we removed BMW because we cannot save this. Watch here, we removed, and here we can delete this now, and as you can see here, we removed BMW. So you can also use the remove method to work with the value that's being removed from a list, but let's remove the value of the Jeep and print a reason for removing it from the list. So now first we are printing the raw car makers without any manipulation, and after that let's too expensive here, expensive, and here we have Jeep here, and now car makers start remove too expensive here and print car makers, and after that we will print this some formatted text here. So first we will write in Jeep, so in this case too expensive, that title is removed, so is too expensive for me. That's it. Here you can see here Jeep is too expensive for me, and we removed Jeep from our list. After deciding the list here, let's actually explain this code one by one. So after defining the list, we assign the value Jeep to a variable called too expensive. So when we use this variable to tell Python which value to remove from the list, and here let's actually, I need my marker now to draw some things on the screen, and here. So here we use this value here. We used this value to remove Jeep here. So the value Jeep has been removed from the list here, but it's still like accessible through the variable too expensive, right? So allowing us to print a statement about why we removed Jeep from the list of car makers.
Often, your lists will be created in an unpredictable order because you can't always control the order in which your users provide their data, right? So, although this is unavoidable in most circumstances, you will frequently want to present your information in a particular order. Sometimes you will want to preserve the original order of your list, and other times you will want to change the original order. So, Python provides a number of different ways to organize your lists depending on the situations. We can also sort a list permanently with a sort method. Now let's create a new list here. Let's cars, and it's going to be BMW, BMW here, cars, BMW, Audi here, Jeep, Jeep here, again Toyota, and Kia, Honda. And here, so Python sorts method makes it relatively easy to sort a list. Imagine we have a list of cars that we write here, and we want to change the order of list to store them alphabetically. To keep the task simple, let's assume that all the values in the list are lowercase, and here we will use the cars.sort here, and that's it. And after that we will print this here, and print cars. So here the sort method changed the order of the list permanently, and the cars are now in an alphabetical order, and we can never revert the original order here. So you can also sort this list in reverse alphabetical order by passing the argument reverse true here, like this. So we pass the argument this reverse true to the sort method, and now this will give us a reverse order here, but again it will sort our list. So again, the order of the list is permanently changed. So the sorting the list is temporarily with a sorted function. So we can also sort the list temporarily with the sorted function. So let's try this now. So to maintain the original order of the list but present it in a sorted order, you can use the sorted function. The sorted function lets you display your list in particular order, but it doesn't affect the actual order of the list. Let's try this function on list of our cars that we created here: BMW, Audi, Jeep, Toyota, Kia, and Honda. Now we will print here. This is our original list here, and after that we will print the cars, and after that we will print again. This is a here. Let's actually use the new line. So this is a sorted list, and after that we will print the sorted cars here, and after that we will print the list again. This is our original list. That's it. Here now I will explain this code one by one. So we first print the list in its original order here, and then in alphabetical order here. After the list is displayed in a new order, we show that the list is still stored in its original order here. Sorry for that. Let's add the print cars here again. As you can see here, these are the two same original orders. So after presenting it in sorting it out, even we can use the original owner of the list. So here, notice that the list still exists in its original order, and after the sorted function has been used, the sorted function can also accept reverse true here, and argument if you want to display a list in reverse alphabetical order. And sorting a list alphabetically is a bit more complicated when all the values are not in lowercase. So there are several ways to interpret capital letters when determining a sort order, and specify the exact order can be more complex than we want to deal with at this time. However, most approaches to sorting will build directly on what you learned in this section. To reverse the original order of a list, you can use this reverse method. So if we were originally stored the list of cars in chronological order according to when we owned them, we could easily rearrange the list into reverse chronological order like this. For example, let's delete here and print cars firstly, and after that we will cars.reverse here, and after that we will print the cars again. So notice that the reverse doesn't sort backward alphabetically, it simply reverses the order of a list. So here we have Honda 1 first here, Kia second, Toyota third, Jeep fourth, Audi fifth, and BMW last year in sixth. This is how reverse method works. So the reverse method changed the order of list permanently, but you can revert the original order anytime by applying the reverse again, right? Like logic here. And as you can see here, we apply the reverse second time and we have the original list, original order. So we can find the length of a list as well. So you can quickly find the length of a list by using the len function. So now firstly use this print len here, and after that we will enter our list. And here, as you can see, we have 6 items. 1 2 3 1 2 3 4 5 6 items here. We have 6 items here. And you will find len useful when you need to identify the number of aliens that still need to be shut down in a game. Determine the amount of data that you have to manage in visualization, and or figure out the number of registered users on a website, among other tasks. So Python counts the items in a list starting with 1, so you shouldn't run into any off by 1 errors when determining the length of a list. And also you should avoid the index errors when working with a list here. So there's one type of error that's common to see when you are working with a list for the first time. So let's say you have a list with 3 items here. Let's actually, instead of BMW, Audi, and Jeep, right? So you have a list of 3 items, BMW, Audi, and Jeep. If you let's delete this as well. If you print the 3 here, this example will give us an index error. So Python attempts to give you the item at index 3, but when it searches the list, no item in cars has an index of 3. Because of this off by 1 nature of indexing in lists, this error is typical, and people think the third item is item number 3 because they start counting at 1. But in Python, the third item number is 2 because it starts from the 0. It starts from 0, 1, and 2. So there's no thing in this list such as 3, right? So if you want to reach the last item, you should enter 2 instead of 3. Okay, that's why we got the list index out of range error. So an index error means Python can't find an item at the index you requested. So if an index error occurs in your program, try adjusting index you are asking for by 1. So then run the program again to see if the results are correct. And here keep in mind that whenever you want to access the last item in a list, you should use the index -1, and this will always work even if your list has changed size since the last time you accessed it. So the index -1 always returns the last item in a list. In this case, the value is Jeep here. And the only time this approach will cause an error is when you request the last item from an empty list. And as you can see here, list index out of range. And here we have no items in cars for now. So Python returns another index error. If an index error occurs and you can figure out how to resolve it, try printing your list or just printing the length of your list, and your list might look much different than you thought it did, and especially it has been managed dynamically by your program. And seeing the actual list or the exact number of items in your list can help you sort out such logical errors. So in this section you learned what lists are, how to work with the individual items in a list. You learned how to define a list and how to add and remove elements. You learned how to sort lists permanently and temporarily for display purposes. You also learned how to find the length of a list and how to avoid index errors when you are working with lists. In previous section, you learned how to make a simple list and you learned to work with the individual elements in a list. And in this section, you will learn how to loop through an entire list using just a few lines of code, regardless of how long the list is. So looping allows you to take the same action or set of actions with every item in a list. As a result, you will be able to work efficiently with a list of any length, and including those with thousands or even millions of items. So you will often want to run through all entries in a list, performing the same task with each item. For example, in game, you might want to move every element on the screen by the same amount. In a list of numbers, you might want to perform the same statistical operation on every element. Or perhaps you will want to display each headline from a list of articles on a website. So when you want to do the same action with every item in a list, you can use Python's for loop. So let's say we have a list of magicians' names and we want to print out each name in the list. We could do this by retrieving each name from the list individually, but this approach will cause several problems. For one, it will be repetitive to do this with a long list of names. Also, we'd have to change our code each time the list length changed. So using a for loop avoids both of these uses by letting Python manage these uses internally. So let's use for loop to print out each name in list of car models or car makers. So car makers here, and we will use the BMW, or Kia here, Ford, Dodge here, Dodge, and we will also use, for example, BMW, Kia, Mercedes, or it was, yes, Mercedes, and Volkswagen, and so on. So now that's enough actually. So 0, 1, 2, 3, 4, 5 on index and 6 items. So we begin by defining list, and now we will write our for loop. So for cars or makers, you can do here makers. You will understand what these makers or cars are. Instead of using makers plural, we can use one here. So car in car makers, and after that we will use double dot here and we will print the car. That's it. So now I will explain all of this code here. So we begin by defining a list, just the regular list, just as we did in previous lectures, and as you can see here, it's car makers. So let's, instead of using red, you can also use another color here. So we define the list of car makers, and here the next we tell Python here, and also firstly here we have for loop. Look at this. So this line tells the Python to pull a name from the from the car makers and associate it with the variable car, right? So, and next we tell the Python to print the name that has been assigned to car here. So here, as you can see here, we printed each of line this BMW, Kia, Ford, Dodge, Mercedes, and BMW in separate print functions here. So, and Python repeats these last two lines once for each name in the list. It might help to read this code as for every car maker in the list of car makers, print the car maker's name, right?
So the output is going to be this, as you see here. So now let's take a closer look at this loop here. So looping is important because it's one of the most ways a computer automates repetitive tasks. For example, in a simple loop like we used in this Python here. So Python initially reads the first line of the loop, which is for car in car makers. So this tells Python to retrieve the first value from the list car makers and associate it with the variable car, right? So this first value is here BMW, and Python rates the new line here, and Python prints the current value of the car makers, which is BMW, because the list contains more value. So and Python returns to the line of the first loop. So now Python retrieves the next name in the list, which is Kia here, Kia, and associates with the value with the variable magician. So here we have firstly in first loop here we had BMW, secondly we had Kia here, in third loop we had Ford, and here Python prints the current value of car again, which is now here, right? And Python repeats the entire loop once more with the last value in the list. In this case, Ford, and then Dodge, Mercedes, and lastly Volkswagen. And after that, we are ending this loop, and here we printed all the loop. So when you are using loops for the first time, keep in mind that the set of steps is repeated once for each item in the list. So no matter how many times items are in the list. So if you have 1,000,000 items in your list, Python repeats these steps 1,000,000 times, and usually very quickly. And also keep in mind when writing your own for loops that you can choose any name you want for the temporary variable that will associate it with each value in the list. You can do, for example, my car make or so on. And of course you have to change the my car make here. That's it. However, it's helpful to choose the meaningful name that represents a single item from the list. For example, instead of doing cars here, writing this for cars in car makers, or for dogs in dogs, you can write for dog in dogs here, or for cat in cats, because this first item represents just one item, but here this represents the list in this case. The naming conventions can help you follow the action being done on each item within a for loop. Using a singular and plural names can help you identify whether a section of code is working with a single element from the list or the entire list. You can do just about anything with each item in a for loop. Let's build on previous example by printing a message to each car makers, telling them that they performed a great model, or let's actually tell them that what their models and great car. Let's actually, instead of telling what they are, let's provide just a great car, right? The only difference here we will make, so I will tell you right now, in this code we will compose a message to each car make, starting with the car makes make, right? So in this we will print this, we will use the format again, and the car, oops, not like this. Here inside this format we will car make and title, and this was a great car, great car. And after that, let's print this out. And as you can see here, the only difference in this code is where we compose a message to each car model, starting with the car model's name, and after that we are telling our message.
So the first time through the loop, the value of car make is BMW. So Python starts the first message with the name of BMW, and the second time through, the message will be the Kia here, right? So and here, as you can see here, the Kia, and the third time through, the message will be Ford. Fourth time is gonna be Dodge. The fifth time is gonna be Mercedes, and the sixth time is gonna be Volkswagen. So you can also write as many lines of code as you like in the for loop. Every intended line following in the line for car make and car makers is considered inside the loop. So here, this is the outside the loop, but if we write the tab here, and this is inside the loop, so it will loop inside here every time our loop works. So therefore, you can do as much work as you like with each value in the list. So let's add a second line to our message telling each car makes that we are looking to their next trick. And now, in order to do that, we will use this inside here. So we will print this again. We will use the format, and cars are great car. And now we will something car here. So now we will do this, that BMW or MPG is high on, or let's actually miles per gallon, and yes, miles per gallon is high on this car. For example, in this case, we will use car make. And now let's run it. And as you can see here, the BMW great car, miles per gallon is high on BMW. Kia great car, miles per gallon is high on Kia. Ford great car, miles per gallon is high on Ford. And here, because we indented both cars to print here, each line will be executed once for every car make in the list. So the new line, let's actually use the new line here and see how this output will change. And as you can see here, a new line in the second print calls insert a blank line after each pass through the loop. So this creates a set of messages that are neatly grouped for each car make on the list. So now let's run this list here. So this is our first iteration. So this is our first loop, second loop, third loop, fourth loop, fifth loop, and sixth loop. And here our loop ends because we do not have any item into the list, and that's why our loop breaks here. That's it. So oops, let's actually fix that. And here, that's it. So here you can use as many lines as you like in your for loops. In practice, you will often find it useful to do a number of different operations with each item in a list when you use a for loop. What happens once a for loop has finished executing? Usually you will want to summarize a block of output or move on to other work that your program must accomplish. Any lines of code after the for loop that are not intended are executed once without repetition. So let's write a thank you to group of car makers as a whole, and thanking them for putting on an excellent cars. So to display this group of message after all of the individual messages have been printed, we place the thank you message after the for loop without the indentation here. So now we will write print and thank you every
car makers. These cars are special and great. And here, now let's run this and you will see, or this message is just executed once. So the first two calls to print are repeated once for each car makers in the list, as you saw earlier. However, because the last line is not intended, it's printed only once. If we add indentation to it, you will see, as you can see here, thank you every car makers, thank you every car makers, thank you every car makers, and so on. Yeah, so we will delete this indentation and we will get this thank you message only once, because it's not included in this loop because of the indentation we didn't put before the print here. So when you're processing data using the for loop, you will find that this is a good way to summarize an operation that was performed on an entire dataset. For example, you might want to use a for loop to initialize a game by running through the list of characters and displaying each character on the screen. You might then write some additional code after this loop that displays a play now button after all the characters have been drawn to the screen. Python uses indentation to determine how a line or group of lines is related to the rest of the program. In this examples, the lines that printed messages to individual car makers were part of the for loop because they were indented. So Python's use of indentation makes code very easy to read. Basically, it uses white space to force you to write neatly formatted code with a clear visual structure. In longer Python programs, you will notice blocks of code indented at a few different levels. These indentations levels help you gain a general sense of the overall program's organization. So as you begin to write code that relies on a proper indentation, you will need to watch for a few common indentation errors. For example, people sometimes indent lines of code that don't need to be indented, or forget the indented lines that need to be indented. So seeing examples of these errors now will help you avoid them in the future and correct them when they do appear in your own programs. So now let's examine some of the more common indentation errors. So you can also forget the indent. Always indent the line after the for statement in a loop. If you forget, Python will not remind you here. And as you can see here, expected an indented block. So here, if we write, for example, car makers, and just delete this indentation, get an error also. So let's actually delete this and I will explain all of this. So the call to print should be indented. So, but it's not here. So when Python expects an indented block and doesn't find one, it lets you know which line it had problem with. And if we run this code again, and let's run here, and as you can see, we have an indentation error as line 3. So you can usually resolve these kinds of indentation errors by indenting the lines or lines immediately after the for statement. You can also forget to indent additional lines. So sometimes your loop will run without any errors but won't produce the expected result. So this can happen when you are trying to do several tasks in a loop and you forget to indent some of its lines. For example, this is what happens when we forget to indent the second line in the loop, and here we will not get any error here. And now if we run this, and as you can see here, list object has no attribute title. As a result, the first print And that if makers here, this code will, and as you can see, let's karmic, oops, karmic. This code will run without a problem. We just edit this, and if we change this to karmic, and we will get this as well. So here, as the result here, the first printf call is not indented, and so the first, that's why first print call is executed once for each name in the list, because it's indented. But here the second print call is not indented, so it's executed only once after the loop has finished running, because the final value associated with Volkswagen here, and Volkswagen is the only one who receives the looking who receives the thank you every car makers. These cars are special and great, and Volkswagen only one who gets the miles per gallon is high on Volkswagen. And here, this is a logical error. This syntax is valid Python code, but the code does not produce the desired result because a problem occurs in its logic. So if you expect to see certain action repeated once for each item list, and it's executed only once, determine whether you need to simply indent a line or group of lines. So here, that's now we are getting this error here, because in for loop, if you have a for loop here, for now, this print message will execute at once, but your program firstly execute your for loop again, and again, and then after completing the for loop, it will go to next lines here. Many reasons exist to store a set of numbers. For example, you will need to keep track of the positions of each character in a game, and you might want to keep track of players' high scores as well. In data visualizations, you will almost always work with a sets of numbers such as temperatures, distances, population size, or altitude, longitude values, among other types of numerical sets. So lists are ideal for storing set of numbers, and Python provides a variety of tools to help you work efficiently with lists of numbers. So once you understand how to use these tools effectively, your code will work well even when your list contains millions of items. So you can also use the range function. So Python's range function makes it easy to generate a series of numbers. For example, you can use the range function to print a series of numbers like this for my value here in range, for example, from 1 to 10, and here we will print my value. And here you will see, and here you will see range from 1, 2, 3, 4, 5, 6, 7, 8, 9 here. So although this code looks like it should print the numbers from 1 to 10, it doesn't print the number 10. In this example, range prints only the numbers from 1 through 10. So I want to explain this by drawing something on the screen here like that. For example, this is range here. For example, we wanted variable 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, and 10. Here we when we ask range for a number from 1 to 10, it will give us from here and from 1 to 9. So this is the number this code will give us here. So as I said, in this code, the range prints only numbers from 1 through 10 through 9. Let's run it again, and here, so this is another result of the off by 1 behavior you will see often in programming languages, and the range function causes Python to start counting at the first value you give it, and it stops when it reaches the second value you provide. Because it stops at the second value, the output never contains the end value, which would have been 10 in this case. To print numbers from 1 to 10, you will do this. Just 11, write 11, and that's it. Here, as you can see, we printed values from 1 to 10. So if your output is different from what you expect when you are using range, try adjusting your end value by 1. So you can also pass range only one argument, and it will start a sequence of numbers at 0. For example, range 6 here will return the numbers from 0 to 6. So you can also use the range to make a list of numbers. So if you want to make a list of numbers, you can convert the results of range directly into a list using the list function. So when you wrap list around the call to range function, the output will be a list of numbers. In this example, the previous section, we simply printed out series of numbers, and we can use list to convert that same set of numbers into a list. So in order to do that, we will do numbers, or my special numbers, numbers equals list here, and range 1 6 or 11 here. So now we have to add here, and we will add, after that we will print the my special numbers. That's it. Here you can see the 1 2 3 4 5 6 7 8 9 10. So we can also use the range function to tell Python to skip numbers in a given range. If you pass a third argument to range here, Python uses that value as a step size when generating numbers. For example, here's how I list the even numbers between 1 and 10. We will do here 2, and we will do 2 here again, and here, and as you can see here, 2 4 6 8 and 10. So in this example, the range function starts with the value 2 and then adds 2 to that value. It adds repeatedly until it reaches or passes the end value 11. I want to also illustrate this on screen here. So here we have 1 2 3 4 5 6 7 8 9 7 8 9 10 here. So here what you see is, so here we are saying that we will start from 2 and end from 10 11, but this means 10 here, as we explained here. So we will start from the 2 here. So we will start first from this 2 4, because as you can see here, we are passing 2 in each number, and then we come here, and here we go to 6, and here we come here, and here we go to 8, and here we are, and then we are going to 10, and this is where our range ends. So you can create almost any sets of numbers, or you want to use you can also create almost any set of numbers you want to using the range function. So for example, consider how might make a list of the first 10 square numbers, that is the square of each integer from 1 through 10 in Python, which is 2 asterisks like that. So let's actually close this. So now here's how you might put the first 10 square numbers onto a list. So here we have a my special, or my squares here, and here we will create an empty list. Now we will use the for loop, my value here in range, and here we will start from 1 to 11, and here we will use the my squares here equals my value asterisk 2, and dual asterisk here, and 2, and here we will use my squares here that append or my value here, here my squares that append or my square here, and we will change it my square equals my value asterisk 2, and here we will use my squares that append the my square, and that's it. And after that, of course, we will need to print the squares here, but outside the for loop. As you can see here, we are printing outside the for loop. Squares here, or my square. Yeah, that's it. Now let's run it. And as you can see here, 1, 4, 9, 16, 25, 38, 49, 64, 81, and 100. So we start with an empty list called squares here. Actually, let me here. So here we start with the empty list called my squares. Here, let's actually use that marker. So here we start with the empty list called my squares. Then we tell Python to loop through each value, from 1 to 10. In this case, we write 11 using the range function. So inside the loop, the current value is raised to the second power and assigned to the variable my square here. Each new value of square is then appended to my square list here. As you can see here, we are using append here. So this works like that. For example, this is our my squares here, and here we added, and then another loop comes, we added another value, and then another loop comes, we added another value inside it, and until the 10 times here. So that's it. And finally, when the loop has finished running, the list of squares is printed on the screen. In previous lectures, you learned how to access a single element in a list, and in this section, you've been learning how to work through all the elements in a list. So you can also work with a specific group of items in a list called a slice in Python. So to make a slice, you specify the index of the first and last elements you want to work with. As with the range function, Python stops one item before the second index you specify. The output of the first three elements in a list you will request here indicates truth 0 to 3 here. So now if we write 0 to 3 here, we will get this here, and this is our slice. So here I will create some examples here. So let's again make some example about car makers, or let's sometime now car makers is okay. Car makers, here we will add BMW, Honda here, we will add Volkswagen, we will add the Ford, Hyundai, Kia, and Nissan here. So here we will print the 03. So print car makers 03 here. So this code now this code prints a slice of the list. So the output retains the structure of a list and includes the first three car makers in the list here. So in this case, it's gonna print us here. It's gonna print us BMW, Honda, and Volkswagen. So it will print us these three items since we write in 0 and 3 here. So now let's print this, and as you can see here, BMW, Honda, Volkswagen. So you can generate any subset of a list. For example, if you want to if you want to second, third, and fourth item in a list, you will do this. Here, as you can see here, we started Honda, Volkswagen, and Ford. And this time, the slide start with Honda here and ends with the Ford. So if you omit the first index in a slice, Python automatically starts your slice at the beginning of the list, like this here. You just need to add this double dot here. And as you can see here, we got BMW, Honda, Volkswagen, and Ford here. So, a similar syntax works if you want a slice that includes the end of a list. So, for example, if you want to all items from the third item through the last item, you can do this. 2 double dot, but this double dot here will come after the number to get the last item. So here, get from the last item. Now, in this case, we will get, as you can see here, it's actually, where's my marker? Yes. So here we got Nissan, Kia, Hyundai, Ford, Volkswagen, and that's it. We got from here to here. So we got 2 here. We counted 0, 1, second. And from second, we told Python that get all those items from the last. So Python returns all the items from the third item through the end of the list. Volkswagen, Ford, Hyundai, Kia, Nissan. So this syntax allows you to output all the elements from any point in your list to the end, regardless of the length of the list or something. So recall that negative index returns an element a certain distance from the end of a list. Therefore, you can output any slice of the end of a list. For example, if you want to output the last 3 car makers on the car makers, we can use this slice like this here. -3, -3 here, and this double dot here, and after that we will print this. And as you can see here, we printed Hyundai, Kia, Nissan here. So you can include a third value in the braces, indicating a slice. So if a third value is included, this tells Python how many items to skip between items in the specified range. So you can use a slice in a for loop if you want to loop through the subset of the elements in a list. So in this example, we will loop through the first 3 car makers and print their names as a part of a simple car maker. Now we will print here. Here are the first 4 car makers in my list here. And after that, we will use for loop for car maker in car makers. And here we will enter this. Here for, and after that we will print here. We will print the car maker dot title. So here we will, let's run this, and as you can see here, we got this example. We got this output. So instead of looping through the entire list of players or car makers, Python loops through only the first 4 car makers. So slices are very useful in a number of situations. For instance, when you are creating a game, you could add a player, you could add a car maker's model to a list every time that that car is running or playing, the player is playing with that car. So you could then get a player's top 3 scores by sorting the list in decreasing order and taking a slice that includes just the first 3 scores. often you will want to start with an existing list and make an entirely new list based on the first one. So let's explore how copying a list works and examine one situation in which copying a list is useful. So to copy a list, you can make a slice that includes the entire original list by omitting the first index and the second index, like this, right? So this tells Python to make a slice that starts at the first item and ends with the last item, producing a copy of the entire list. For example, imagine we have a list of our favorite car makers and want to make a separate list of car makers that our friend drives. So this friend likes everything in our list and drives everything on our list so far, so we can create their list by copying ours. So in order to do that, you will write friend that likes cars, and here we will use this, and let's actually my favorite cars, and here friend's favorite car, and here now we will use this my favorite cars and this, and after that we will firstly print this friend's favorite cars, and after that firstly, of course, this is the friend's favorite cars and this is my favorite cars, and after that we will first print the my favorite cars. So print my favorite cars are like this, and after that we will print our my favorite cars, and after that we will print, of course we need to add a new line before it, so my friend's favorite cars are here, and after that we will print friend's favorite cars, and here we will run this now, and as you can see, this is our output. So I added this new line here. Oops, sorry, again, it's not working, or yes, it's working now. Okay, so here I added this new line character to this to show our output new line here. So I could be added this new line after the my favorite cars here, but it's more easy to add here instead of writing some formatting and things in last my favorite cars print function. So first we make a list of car makers we like, called our favorite car makers, called my favorite cars. Then we make a new list called friends favorite cars, and we make a copy of my favorite cars by asking for a slice of my favorite cars without specifying an indicator like this here, and assign the copy of my favorite cars to friends favorite cars. So when we print each list, we see that they both contain the same cars. So to prove that we actually have two separate lists, we will add a new car to each list and show that each list keeps track of the appropriate person's favorite car. So in order to do that, we will do after my favorite cars here, we will do my favorite cars that append here. Let's add new car maker name. In this case, Toyota, right? So Toyota. Oops. Toyota here, and after that we will also add friends favorite cars, and we will append the let's add Fiat, right? And here we will not change this print functions, And now we will run our code and see what will change here. And as you can see here, so we copy the original items in my favorite cars to the new list called friends favorite cars, as we did in the previous example. And next we add a new car maker to each list, and we add Toyota to my favorite cars, and we add Fiat to friends favorite cars. And when and we then print the two lists to see whether whether each of these favorite cars is in the appropriate list. So here the output shows that our Toyota appears in our list of favorite cars, but Fiat does not. So we can see that Fiat now appears in our friends list, but Toyota doesn't, right? If we had a simply set friends favorite cars equal to my favorite cars, we will not produce two separate lists. For example, here's what happens when you try to copy a list without using a slice. Oops. Without using a slice. And as you can see here, we both have Fiat. So instead of assigning a copy of my foods to my favorite cars to my friend's favorite cars, we set a friend's favorite cars equal to my favorite cars. So this syntax actually tells Python to associate the new variable to my favorite cars with a list that is already associated with my favorite cars. So now my favorite cars, it will also appear in friends favorite cars, and so on. So likewise, the Toyota will appear in both lists, even though, or Fiat will appear in both lists, even though it appears to be added only to my favorite cars. And as you can see here, Toyota and Fiat appears in the same list. So the output shows that both lists are the same now, which is not we wanted here. And don't worry about the details in this example for now. If you are trying to work with a copy of the list and you see unexpected behavior, make sure you are copying the list using a slice, as we did in this in the first example here. Lists work well for storing collections of items that can change through the list of a program. So the ability to modify lists is particularly important when you are working with a list of users on a website or a list of characters in a game. So, however, sometimes you will want to create a list of items that cannot change. So tuples allows you to do just that. So Python refers to values that cannot change as immutable, and immutable list is called tuple. So a tuple is just like a list, except you use parentheses instead of a square braces. Once you define a tuple, you can access individual elements by using each item's index, just as you would for a list. For example, if we have a rectangle that should always be a certain size, we can ensure that its size doesn't change by putting the dimensions into a tuple. So my dimensions here, we will add 250 here and 100 here, and here we will print first we will print dimension 1, and then we will print oops, not like that. Of course we need to get a variable name. So my dimensions 1 here, and here, as you can see here, we define the tuple dimensions using the parentheses instead of a square braces like we did in lists. So then we print each element in the tuple individually using the same syntax we have been using to access elements in a list. And as you can see here, we first printed 250 and 200 after that. So and actually let's see what happens if we try to change the items or change one of the items in the tuple dimensions. Now here we will write my dimension. Actually, let's name it my tuple, right? So it will be more explanatory. My tuple dimensions, and here we will use the my tuple dimensions equal 0. Let's make 0 to 150 here, and after that print this my tuple dimensions 0, and after that print my tuple dimensions 1. And here, so this is the error we got here. Actually, delete this for now. So this code tries to change the value of the first dimension, but Python returns a type error because we are trying to alter a tuple, which can't be done to that type of object. And Python tells us we can't assign a new value to an item in a tuple here. As you can see here, tuple object does not support item assignment. So this is beneficial because we want to Python raise an error when a line of code tries to change the dimensions of the rectangle. And tuples are technically defined by the presence of a comma. So the parentheses make them look neater and more readable. So if you want to define a tuple with one element, you need to include trailing comma here. So if you want to define tuple just one element, you need to include this trailing comma. Yeah, so it doesn't often make sense to build a tuple with one element, but this can happen when tuples are generated automatically. So you can also loop through all values in a tuple. So you can loop over all the values in a tuple using just a for loop, just we did in previous lectures with lists. So here now we will add new tuple. So my tuple or my car models, my favorite car models that I will like forever. And this is not the best name for that, but I've just general explanatory purposes. And here we will add tuples that, for example, I like BMWs, I like here, for example, I like Volkswagen, but the sporty ones. Here I like Fords here. So that's it, Ford. And here we will loop through all the tuples in this list. So so remember, this is not a list. This is actually, let me here. So remember, keep in mind that this is not a list. This is tuple. This is tuple here. So here we will loop through all the items in this list. So for my fave car, and here we will do in my favorite car models that I will like forever. And here we will print here my fave car, and let's print this. And here, as you can see here, we loop through all the elements here. So Python returns all the elements in a tuple just as it would for a list. So although you can modify a tuple, so that's it how this works here. So although you can't modify a tuple, you can assign a new value to a variable that represents a tuple. For example, if you wanted to change the dimensions of a previously created rectangle dimensions, here for example 250 and 100, and we will print the original dimensions here, original dimensions here, and after that we will create a for loop, dimension in dimensions, and after that we will print here, we will print the dimension, and here we will, after that we will do again dimensions. We will change the dimensions here, dimensions, and equals, for example, 500 and 200, right? And after that we will print this new line, modified dimensions, and here we will create a new for loop. Actually, let's use double dots here, make it look nicer, right? So for dimension in dimensions, and here we will print dimension again. That's it. And here we will, let's run it. That's it. And here this is our output. So the first 4 lines defines the original tuple and print the initial dimensions, and we then associate a new tuple with the new variable dimensions and print the new value. And Python doesn't raise any error this time because reassigning a variable is valid. So when compared with list, tuples are simple data structures and use them when you want to store a set of values that should not be changed throughout life of a program. Conditional programming or branching is something you do every day, every moment. It's about evaluating conditions. If the light is red, then I can cross. If I'm hungry, I need to eat. And if I'm late for work, then I will call my boss. And the main tool is the if statement, which comes in different forms and colors, but its basic function is to evaluate an expression and based on the result choose which part of the code to execute. As usual, let's look at this example here. So if I am is late here and true here, true, and after that we will, if is late is true, then print I need to call my boss. And this is possible the simplest example. So when fed to if statement, the is late acts as a conditional expression which is evaluated in a Boolean context. And remember that is late here, this is late variable here is Boolean, not string, not value, tuple, or anything. It is a Boolean. It's another primitive type, Boolean. You will learn about that in next lectures also. So Boolean also can, Boolean has two values, either false or true. So if the result of the evaluation is true, then we enter the body of the code immediately after the if statement. Notice that the print instruction is indented, which means that it belongs to scope defined by the if here, and as you can see, this is indentation here. So if we run this code, as you can see, I need to call my boss. If we make it is late false, so we are not late for now, and as you can see, we didn't evaluate anything. So this code didn't work or didn't need it to work here. So depending on the result of evaluating the late is late expression, we can either enter block 1 or block 2, but not both. So block 1 is executed when late evaluates to true, while block 2 here is executed when the late evaluates to false. So try assigning false and true to this is late to see how the output of this code changes accordingly. So in this example, also introduced the else clause in which becomes very handy when we want to provide an alternative set of instructions to be executed when an expression evaluates to false within an if clause. So the else clause is optional, as is evident by comparing preceding two examples, and with these examples we will do in next lecture. So I'm waiting you in next lecture. Often you will want to take one action when a conditional test passes and different action in all other cases. Python's if-else syntax makes this possible. The if-else block is similar to a simple if statement, but the else statement allows you to define an action or set of actions that are executed and run when the conditional test fails. When the if test fails, and in this case we will execute else. So we will display some message here. Now let's write something that, for example, we have a car here, and actually let's draw a car here. And we don't want this car to for example, older than 10 years, right? So let's make this 10 years. So we want this car to less than 10 years, so we will want a new car, right? And that's why we're gonna do here that. Let's make, for example, car model. Here it's going, in this case, let's make it BMW. And car year, in this case, let's make it 2015. And here we will add if our car model, so car year minus 2023. In this case, of course, today's year is 2023. And actually, let's delete this for now. Also delete this. And now, car year minus 2023 is, so our car year, for example, in this case, our car year is going to be 8. While 8 is less than 10, then it will evaluate 3, right? So in this case, print your car is, and we will also use format here. Format your car is car year minus 2023 years old, and it's almost new, right? And here we will also add else statement. If our car has age of more than 10, we will write this here, else print sorry, I don't want, or sorry, our company doesn't buy cars that more that age is more than 10. And after we will print again, and your car age is, of course we need to add F here, format car year minus 2023. Your car, or yes, actually instead of car we can also write BMW, right? So, or car model is years old and it's almost new and we can buy it. And here in else, sorry, our company doesn't buy BMW. Let's actually add another format here. So we will add F here and format car model that age is more than 10 and car year here. Now let's run this. And as you can see here, your BMW, oops, actually we need to do this opposite here. Sorry for this. We got right numbers, but we got negative here. So we need to do this. We need to subtract our car year from 2023. Let's do the same here. And now your BMW is 8 years old and it's almost new. We can buy it. But in else here, else command here is didn't execute it because if here evaluated true. If we make our car year, for example, 2005, then it will give your BMW is 18 years old and it almost, no, oops, car year, of course we need to change it again, 2023 minus car year, and here we will get else here. Sorry, our company doesn't buy BMW that age is more than 10 and your car age is 18. So in first example, actually, let's try again, 2015. So in this example, our if conditional test passes and the first block of this print here call is executed. So if the test evaluates to false, then the else block is executed. For example, 2005, and in this case, our false will not be executed because it is here, because it is false, right? So it will not execute. Instead, our else command here will execute here. So this code works because it has only two possible situations to evaluate. A car is either old enough or not, right? So the if-else structures works well in situations in which you want Python to always execute one of possible situations or actions. So in a simple if-else chain like this, one of two actions will always be executed, no matter if our car year is 1000 or some here. As you can see, sorry, our company isn't by BMW, that age is more than 10. Programming often involves examining a set of conditions and deciding which action to take based on these conditions. Python's if statement allows you to examine the current state of a program and respond appropriately to that state. In this section, you will learn to write conditional tests, which allow you to check any condition of interest, and you will learn to write simple if statements, and you will learn how to create a more complex series of if statements to identify when the exact conditions you want are present. And you will then apply this concept to lists, and so you will be able to write a for loop that handles most items in a list one way, but handles certain items with specific values in different way. So this example here, we will show the if tests that let you respond to special situations correctly. Imagine you have a list of cars and you want to print out the name of each car. So car names are proper names, so the names of most cars should be printed in title names, title case. However, the value BMW here should be printed in all uppercase, and here we will do that right now. So we will car makers here, and after that we will equal to. So first we will enter the Volkswagen, the BMW, the Toyota, Ford, and Jeep. And here we will use the for car in car makers. And here, so if car equals to BMW, then we will print the car dot upper, and else, here we will print the car dot title. That's it. So now let's run it. That's it here. If BMW, if BMW, that's it. Now this will work here. So now the loop in this example first checks if the current value of a car, is BMW. If it is, the value is printed in uppercase here with this function, right? If the value of a car is anything other than a BMW, it is printed in a title case. And here, this is our output here. All of these names are written in title case, but here BMW is written in uppercase. So this example combines a number of concepts you will learn about in this section. Let's begin by looking at the kinds of tests you can use to examine the conditions in your program. So we can also use conditional tests in Python. So at the heart of every if statement is an expression that can be evaluated as true or false, right? So Python uses the values true and false to decide whether the code is in an if statement should be executed or not. So if a conditional test evaluates true, then Python executes the code following the if statement. So if the test evaluates false, Python ignores the code following the if statement. We can also check for equality. So the most conditional tests compare the current value of a variable to the specific value of interest. So the simplest conditional test checks
whether the value of a variable is equal to the value of an interest. In order to do that, we will just delete for now our for loop, and we will print here now car equals BMW here. Or let's actually, instead of writing that, let's use car makers. BMW's index is 1, BMW, and BMW here. So now, as you can see, we got an error, cannot assign to a function call. So here, that is, we're gonna get an error if you try to do that. However, if you try this in Python console, which we will now, here we opened our Python now. You can reach this by using just Python. And here you're gonna see this Python 64-bit or 32-bit. You just enter that, and here you can see the new tab opened. Here, let's actually make it closer. So most conditional tests are compare the current value of a variable to a specific value of interest. Let's create a new value named car here and make it BMW. And after that, we will check is car equal to BMW. And here you can see we got true. So the first line here, actually, let me get this. So this first line, let me fix this. Now here, this first line here sets the value of a car. Sets the value of a car to BMW using a single equal sign. So here we used the single equal sign here, right? As you've seen many times already, this sign. So the next line checks whether the value of a cars is BMW here. You see here? Oops, actually, let's use different color here. So now we are checking this by using a double equal sign. Double equal sign. Here, car is BMW. So this is an equality operator. So so this equality operator here, this is named equality operator. Let me actually write that here. This is equality operator. So here, this equality operator returns true, like in this case, if the values on the left and the right side of the operator match. In this case, these are matched. So car is actually equals to BMW. Actually, let me use the different color. So here, our car is equals to BMW here, because we already assigned that in first line, and our BMW here equals to BMW, right? So we are checking this BMW. And here they match. In this case, they will return true. That's it. But here the values in this example match, so Python returns true. So when the value of a car is anything other than a BMW, for example, let's try car equal the Jeep here, we will get false. If car equal uppercase B, BMW, we will get false again, because these equality operator are case sensitive in strings. So here, if we try something, ice cream, we will get false again. So that's it here with operators. So a single equal sign is really a statement, and you might read the first line of the code here that we are set the value of a car equal to, for example, Jeep. On the other hand, a double equal sign asks a question.
let me actually write that down. Some new programmers might confuse this with initialization here. So this double equal signs asks this. Let me get this text here. This asks this. So is the value of car equal to BMW? So here our double equal sign asks whether a value of this value of a car in this case is variable, right? Because we use this car as a variable name, and here is the value of car equal to BMW. In this case it's equal, so it will return true. In this lecture, you will learn how to write functions which are named blocks of code designed to do one specific job. So when you want to perform a particular task that you have defined in a function, you call that function responsible for it. So if you need to perform that task multiple times through your program, you do not need to type all the code for the same task again and again. You just call the function dedicated handling that tasks, and call tells Python to run the code inside the function. So you will find that using function makes your program easier to write, read, test, and fix. So let's first design a function now. So now we will def here, greet Typhoon here, and after that we will write this here, print here hello Typhoon, right? Or hello students here. And here after that we will just call that function, in this case greet Typhoon here, and as you can see here we wrote hello students here. And the best thing with functions is you can call that function how many times you want here. So for example, let's write this here, 6 get greet Typhoon here, and as you can see we got 1 2 3 6 hello students message here. So this example shows the simplest structure of a function. The first line, actually I want to draw here so it will be help you to visualize things here. So that's it. So here the first line uses the keyword def here to inform Python that you are defining a function. So here this is the function definition, which tells Python the name of the function here. This is the name of the function here, which we are telling greet Typhoon, and if applicable, what kind of information the function needs to do its job. So in this case we're gonna add this parameters inside this parenthesis here, which you will learn right here. So, and also the parenthesis holds that information. In this case the name of the function is greet Typhoon, and it needs no information and to do his job, right? So its parentheses are empty here, empty here, empty here for now. So even so, parentheses are required. So if you want to define the function, whether it's empty or not, you need that parenthesis here. So it's a basic syntax. So finally the definition ends with this colon here. The definition ends with this colon here, right? So any indented lines here, any indented lines that follow greet Typhoon makes up the body of the function. So here this is the body of our function here. Let me actually take this here. So here body of function. So the text on the second line here, the text on the second line is here the print, right? So here this it look actually here, as you can see, this is the hello student, but we can also get that parameter from something. For example, this, in this case, it's name, right? And here we could do, for example, hello, wherever the parameter we entered, and then name, which you will learn in this section of our course. Here, and the line print hello students is the only line of code in the body of this function. So the Greet Typhoon has just one job, which is print hello students, right? Print hello students. So when you want to use this function, you have to call it. A function call tells Python to execute code in the function. So to call a function, you write the name of the function here, followed by any necessary information in parentheses. So because in our Greet Typhoon function, there's no information needed here, calling our function is as simple as entering Greet Typhoon here, and when we enter this as expected, we write our outputs here, which is hello students. If you modify the function Greet Typhoon slightly, it can greet the user by name. For the function to do this, you enter username in the parentheses of the function definition at here def Greet Typhoon here. So by adding, for example, user name here, you allow the function to accept any value of username you specify. So the function now expects you to provide a value for username each time you call it. So here, let's run this code, and here we got an error because Greet Typhoon missing one required positional argument, which is username, right? So in order to get rid of the error, we need to give some value in it, right? So for example, let's make it one of our student name, for example, Alex here, Alex. And here we got no error, but here the Alex variable here has no use state. So we got to get rid of the error, but we are not using Alex here. So in order to do that, we will write a print function again. So print if hello here, print, we're gonna use format hello dear student, and after that we will use username dot upper here, for example. So we will write Alex name uppercase, and after that we will add this ternary here. That's it. Let's run this, and here hello dear student Alex. So entering Greet Typhoon Alex here, actually let me get this. So entering Greet Typhoon Alex calls Greet Typhoon and gives the function the information it needs to execute print call. So the function accepts the name you passed it and displays the greeting for the name. So let's actually draw this on the screen, how this works on diagrams. So here we are getting the name, some username, right? So in this case, let's call this a username, and after that, whenever some function or some function call uses it here, the Alex actually goes to here, right? So actually let me delete that. Here we will write this again. So here this Alex, we are giving this Alex to this username, right? And after that, this username goes to this print here, which we are printing username.upper. So whenever we call this Typhoon here, first we pass this value to Greet Typhoon, and then Greet Typhoon uses this value inside the print statement, right? So in order now, when we enter the Greet Typhoon at the first here, Alex was like this, Alex here, and here the username here, this is the 6th line, no, 5th line here, and after that we are giving to first line. So in first line Alex is again like this, but here we are printing Alex here. In the second line we are printing Alex but with uppercase. Actually we didn't change it here, Alex here, and as you can see here we've written it in uppercase here. So actually we as you know from previous lectures, we didn't change this Alex variable permanently. So if we use that without, again without the upper method of strings, we will get the Alex that we wrote here. So likewise, entering the, for example, let me actually greet here, and one of our students' name, for example, Murtaza here. And when we try this, we will get same, but with Murtaza here. So again, after using Alex here, so this is our first call, we are calling Murtaza, which is applies the same. Let me actually use the different color here. So we are calling Murtaza. This Murtaza gives the username gets to username here, and after the both here uses the upper method to make it print the uppercase here. So if we do, for example, greet Typhoon here, Nikat here, and this will do the same no matter what. Here Nikat is gonna go here again, Nikat is gonna go here again to username, and username will go to this print function. So you can do this how much you want, whenever you want here. And here in this code here, the greet Typhoon function, we defined the greet Typhoon to require a value to for the variable username, right? So once we call the function and gave it the information, for example a person's or student's name, it printed the right greeting. So the variable username in the definition of greet user is an example. Greet Typhoon here is an example of parameter. So this username, as we said, this is a parameter, right? So for example, we can give, as I said, we can give it whatever value we want. We can even give it an integer here, integers here. Let's try this. And as you can see here, we got error because the upper method, it doesn't exist on integer here. So, and as you can see here, when we deleted the upper, we get rid of an error. We even printed the numbers, which you will learn how to find that and fix that in next lectures. Because a function definition can have multiple parameters, a function call may need multiple arguments. So you can pass arguments to your functions in a number of ways. So you can use positional arguments, which need to be in the same order the parameters were written, keyword arguments where each argument consists of variable name and the value, and list and dictionaries of values. So let's look at each of these in turn. So let's start with the positional argument. So when you call a function, Python must match each argument in the function call, but the parameter in the function definition. So the simplest way to do this is based on the order of the arguments provided. So the values matched up this way are called positional arguments. To see how this works, let's create some code that displays information about courses, and the function tells us what kind of course, so course category is, and the course name. So here we will define describe or get course here, print course here, and we will, and actually instead of writing this, output or display, yes, display course here, we will enter course here. So as a first parameter, we're gonna use the course category or course topic, it's gonna more here. So course topic, and after that we will use comma here and course name. That's it. And after that we will use double dot here, and here we will use the comments, which is display information about course here. And after that we will print using the format, so print here f and new line, of course, after that. So the course name, actually, instead of, let's add another parameter and named course duration, or yeah, course hours, yeah, course hours here. So first we will enter the course topic, and after that we will enter the course topic name, course topic, and again we will print the again format, and after that we will enter the here, and after that we will enter the course name here, and now we will enter course name again, and after that we will again add a new last print function. In this case it's course hours here. Course hours, and after that we will again add the course hours here. That's it. And after that, for example, we will enter the display course here, and course topic, for example, Python with Nihat here, and course name, the course topic is course here. We will in course name learn Python in short, learn Python fast and hard way by Nihat here, and after that we will add another here, course hours, which is 3 hours. Or actually, instead of writing this, let's make course hours integer here, and we will change this course hours and hours here. That's it. So we are taking 2 strings and 1 integer. That's it. Now let's explain this code here. So the definition shows this function needs a type of course. So when we call the display course, we need to provide an course topic and course name and course hours, right? In that order. So first we need to enter the course topic here according to this. Here, course. Actually, instead of writing this, so firstly we are entering the course topic, and then this is our course name, and after that we are entering the course hours, right? So for example, in this function call, the argument Python is assigned to course topic, and in the function body these 3 parameters are used to display information about the course, and we are describing the course here. Now what we're gonna do is here, for example, firstly we are entering the course topic which we are getting from here, and then we are entering the course name which we are getting from the second parameter and writing this, and then we are getting the course hours, which is an integer type, and here we are adding course hours here. Now let's try the output here. Let's see what this gonna show here. So actually let's add 2 spaces to match these up. And as you can see here, course topic is Python, course name is learn Python fast and hard way by Nihat here, and course hours is 3 hours here. So here, as you can see here, we are first adding the 3 here, and then we are adding hours as additional format here. That's it. So we can also add another variables or functions as well. So let's call another here, display course car coolant, or actually let's use the Python or R programming here and learn R programming. Of course, it's going to be a string. Learn R programming, or actually, let's make different name. R programming master class by Nihat here. The course hours is going to be, for example, 10 hours, and after that we are going to show this again. And as you can see here, we got this output here, course topic in Python. Here we are firstly printing Python, and then we are printing the R programming, course topic R programming, course name R programming masterclass by Nihat, and course hours is 10 hours. And as you can see, this is the how we shorted our course here with just adding a function into our code here. A keyword argument is a name value pair that you pass to a function. So you directly associate the name and the value within the argument. So when you pass the argument to the function, there's a new confusion and you won't end up with the, for example, course topic named course hours, right? So keyword arguments free you from having to worry about correctly ordering your arguments in the function call. And they clarify the role of each value in the function call. So now let's rewrite our program using this keyword arguments to call, for example, to call display course here. Now what we're gonna do is course hours here, as you can see here, and course here. And now we can also, when we call display course, right, so we will also mix these up here, right? So now we're gonna use course hours, or course hours here is gonna be 5, for example, and course name or course topic, we can also use course name, but this is just an explanatory here. Course topic is gonna be Python, and the course name is gonna be mastering Python. And here, this is what, and as you can see here, we got the same result, but we mixed up the orders. So here the function display course hasn't changed, but when we call the function, we explicitly tell Python which parameter each argument should be matched with. So when Python reads the function call, it knows to assign the argument course topic to so it knows to assign the variable Python to course topic, so mastering Python to course name. So however, if our order is changed here, so course hours goes to here, our course topic goes to here, and mastering Python, so which is course name, goes to here. So this is mixed up, but however we get the same result with the keyword arguments in Python. So the order of keyword arguments doesn't matter, because Python knows where each value should go. And here in the first here in the second display course call here we used the standard function call, but here we are using the display course which is keyword argument calling. So as I said, it's more clear way to call functions here. So we also have a default values in functions. So when writing a function, you can define a default value for each parameter. So if an argument for parameter is provided in the function call, Python uses the argument value. So if not, it uses the parameter's default value. So when you define a default value for a parameter, you can exclude the corresponding argument you'd usually write in the function call. So using default values, you can simplify your function calls and clarify the ways your functions are typically used. For example, if you notice that most of the calls of this display course are being used to describe courses, so you can set the default value of the course type to just online course, and now anyone calling the display course for a online course can omit that information. And here what we're gonna do here is let's actually delete these lines. So here, so course topic is gonna be just an online course here. So oops, sorry. And here we got an error, and no default parameter follows default here. No parameter follows default parameter. So here we got an error because if we are providing this, we need to also provide the default parameter for all of this. Course name unknown and course hours 0 here, for example. And as you can see, we got rid of an error. Now here we got no problem showing this because we already provided this information for our function. But if we enter some values, for example, if we display course, we just know that this course name, we will do this. So course name here, Java course here, and after that we will not get an error because we already defined this if the default values for this. And here now let's run it here. Actually we did run it, and here course topic is online course. We added just a Java course here, and the course hours is 0 hours because we didn't provide it, and course topic is online course here. And as you can see here, we did this here. So course hours is 0, course name is unknown, but when we enter the Java course, is this unknown here actually emitted here, and we entered the Java course here. And we didn't change or enter the course topic here, and that's why we got the default value, which is online course. So also the order of parameters in the function definition had to be changed because the default values makes it unnecessary to specify a type of course as an course topic as an argument. The only argument left in the function call is the course name here. So when we enter just a Java course here, we will not get an error here, but and as you can see here, we enter the course topic as Java course, but course name is unknown. So I hope you understand it, how this works, and how you should use default values in Python here. A function doesn't always have to display its output directly. Instead, it can process some data and return a value or set of values. So the value the function returns is called return value. So return statement takes a value from inside the function and sends it back to the line that called the function. So return values allow you to move much of your program's grunt work into functions, which can simplify the body of your program. So we will create a simple function that takes the model and make and year and returns a neatly formatted full car information, right? So here we will define get formatted car info here. Actually, if the function names can be descriptive, but I think this is a very long name, which you can also shorten it. For example, get car info, it's better now, right? And here we will get 3 parameters: the car maker, car model, and car year, right? So car year, that's it. And here we will add another command to return a full car info here. And after that we will create a car info here, and we will enter the format, of course, as we always do. And first we're gonna enter car maker, but we will write car maker in uppercase, upper here. And after that we will use the car model. with car model we will use, let's use the title is okay for car model. And now we will enter the year. So we can also get the integer car year, but we can also get the string way. So yeah, I think it's gonna be better if we take car year as a string, as an integer, sorry, not a string. And now we will just print the car model. So here, oops, we did some error here actually. And after that, we will enter car make car model dot title, and after that we will enter the car year. So, and here your car model or car info here in uppercase, and we will enter new lines every time we start this line, and after that return the car info. That's it. And here, yeah, return the car info without a parenthesis here, because this is the variable and not function here. Car info is not function, this is variable. We created variable from these parameters. And here we will let's make it BMW here, and we will use the get car info. First we're gonna enter the car maker. Let's make it BMW, and car model 528 of we will enter it in strings 528e here, which e means here is injection. It's a gasoline here in most of my car manufacturers. And we're gonna enter also car year, for example 2016. And now we will print the BMW. That's it. And here, as you can see, car info BMW 528e, and the year is 2016. So we can also use, for example, in Volvo, so my Volvo here, and get car info Volvo S40, or yeah, S40 is okay. And 2008 here. We can also add another BMW car, or let's add Volkswagen now. Volkswagen car here, get car info, and Volkswagen, and Golf 7, and the year is 2014. That's it. And here, as you can see here, of course we need to print use again, print my Volvo here, my Volvo, and of course let's actually use this with formatting. My Volvo is best here, and after that we will enter the my Volvo variable and print Volkswagen car, and here we will add format Volkswagen is the best here. We can also, and after that we will enter this here, and that's it. And here, as you can see here, we are firstly we are printing car info, then my Volvo is best, and after that we are printing car info Volvo S40, Volkswagen is the best, car info Volkswagen Golf 7 2014. So here, however, when you consider working with a large program that needs to store many first and last names separately, functions like get formatted name or get car info becomes very useful. So you store first and last names, or car maker, car model, and car year separately, and then call this function whenever you want to display a full name or full car info. That's it with today's lectures. And here, let's try this again. And as you can see here, we are using return to get this information from here to here. And as you can see, we are firstly using get car info, which here returns this, and then returns this, and then returns this. And after that, we are printing this. In first, we didn't use any variables to print in BMW. And after that, we added format and entered my Volvo. and then Volkswagen is the best, and after that we are entered formatted info of Volkswagen car.
Object-oriented programming is one of the most effective approaches to writing software. In object-oriented programming, you write classes that represent real-world things and situations. And you create objects based on these classes. So when you write a class, you define the general behavior that a whole category of objects can have. So when you create individual objects from the class, each object is automatically equipped with general behavior. So you can then give each object whatever unique traits you desire. And you will be amazed how well real-world situations can be modeled with object-oriented programming. So making an object from a class is called instantiation. And you work with instances of a class. So in this section, you will write classes and create instances of these classes, and you will specify the kind of information that can be stored in instances, and you will define actions that can be taken with these instances. So you will also write classes that extend the functionality of existing classes. So similar classes can share common functionality, and you can do more with less code. So you will store your classes in modules and import classes written by other programmings into your program files. So learning about object-oriented programming will help you see the world as a programmer or coder does. So it will help you understand your programs, and not just what's happening line by line, code by code, but also bigger window here and bigger concepts behind it. So knowing the logic behind classes or object-oriented programming will treat you think logically, so you can write programs that effectively address almost any problem you encounter. So classes also make life easier for you and other programmers, and you will work with as you take increasingly complex challenges. So when you and other programs write code or programs based on the same kind of logic, you will be able to understand each other's work, and your programs will make sense to the people you work with, allowing everyone to accomplish more. So you can model almost anything using classes. Now we will write a simple class, which here we will create a car. That represents car, but not one car in particular, but any car. So what do we know about most cars? Well, they all have car makers, they all have models and years, and we also know that the most cars are automatic or manual, right? So use three pieces of information, which is car, model, make, and year, and those behaviors, which is automatic and manuals, will go in our car class because they are common to most cars. So this class will tell Python to make a new object representing a car. After our class is written, we will use it to make individual instances, so each of which represents one specific class. So now we're going to create a car class. So each instance created from the car class will store a car model and make. This will be the same variable, and year, and we will give each car the ability to drive and stop. Or actually we can also add automatic and manual, but yeah, we will decide that here. So class car here, class car, and here we will add just a simple program that that written for cars, and here we will use init, but you will learn what init is. So init here, and we will add self name or car model make and model, car make and model, and after that we will enter the year, and after that we will, here we are initializing make and model
model year, and let's actually add the gearbox also, right? Gearbox. So here we will add gearbox. So gearbox can also be automatic, manual. CVT is a different kind of gearbox, but it's still gearbox, right? But in this case, we will add just automatic and manual gearboxes in our cars. So we will also define a new but inside the car class. So here we have this indentation. So here we will define inside this car class the drive. Here we will use self, and that you will understand what these keywords are, and print f here self dot name. Oops, inside the braces here, self dot name or self dot make and model and is now driving. And also we will use make and model. Also we will add year, self dot year, and also we will add self dot gearbox. Gearbox is now driving, right? So for example, BMW 2015, BMW 528 E here, year 2015, and gearbox is automatic, is now driving, right? And after that, we will add another here, another function, which is going to be, let's stop here, right? Let's stop driving, and here we will also add self. So here we will print here with format, and we will copy this. Actually, let's, instead of copying this, let's write this right now here. Self dot car make and model, make and model year, and so gearbox is stopped. That's it. So now I will explain this one by one. So here, oh sorry, it will not return anything because we didn't use this class. We just defined it. We are not using that yet. But here, let's first explain it, and then let's create examples from it. So here, there's a lot of notice here, but don't worry. So you will see the structure through this course, through this section, and have lots of time to get used to it. So first, we define a class called, here we define, oh sorry. So we define a class, sorry, here. Let me actually use my marker. So here we define a class called car. So by convention, capitalized names refer to classes in Python. So there are no parentheses in the class definition here because we are creating this class from scratch. So we then write the doc string. So this doc string here describing here what class does. So actually, let me write this here, doc string. This is a doc string here, and so here we are here seeing init method. So here, oops, actually here. So a function that's part of a class is method. everything you learned about function applies to methods as well. The only practical difference from now is the way we call methods. So the init method here, the init method you are seeing here, actually let me use different color. This init method here, let's make it bigger so you can see the characters. So this init method here is special method that Python runs automatically whenever we create a new instance based on the car class. So this method has two leading underscores and here two underscores and two trailing underscores. A convention that's helped prevent Python's default method names from conflicting with your method names. So make sure to use the two underscores on each side of init. So if you just use one each side, the method won't be called automatically when you use your class, which can result in errors that are difficult to identify. So here we define init method to have three parameters. No, actually 1, 2, 3, 4 parameters. The self, actually let me, yes, here, the self, make and model, year, and gearbox, right? So the self parameter is required in the method definition, and it must come first before the other parameters here. So this should be first, as I said. So it must be included in the definition because Python calls this method later to create instance of car, and the method call will automatically pass the self argument, and every method call associated with an instance automatically passes self, which is a reference to the instance itself. So it gives the individual instance access to the attributes and methods in the class. So when we make an instance of car, Python will call this init here method from the car class, and we will pass car a make and model, a year, and a gearbox as arguments. And self here is passed automatically, so we don't need to pass it. So whenever we want to make an instance from our car class, we will provide values for only the last parameters, which is make and model, year, and gearbox, and not self here. So the two variables are defined in the body of the init method, each have the prefix self here, self, and self, actually not this here, self and self, right? So any variable prefixed with self is available to every method in the class, and we will also be able to access these variables through any instance created from the class. So the line self name here, the line self make and model here, actually let me write another code here. The self make and model, oops, actually let me we will write this here, self make and model equals make and model. Here we will get an error here, self make and model. We will do it inside this. So here, oops, actually let me delete this here. So here self, the line self make and model equals make and model takes the value associated with the parameter make and model and assigns to it the variable make and model, which is then attached to the instance being created. So the same process happens with the self, for example, year or gearbox equals gearbox, and the variables that are accessible through instances like this are called attributes. So the car class has two other methods, which is drive and stop driving. Because these methods doesn't need additional information to run, we just define them to have one parameter, which is self. So the instances we create later will have access to these methods. In other words, they will be able to drive and stop here. And for now, the drive and stop don't do much, and they simply print a message saying that our car model, year, gearbox is stopped, or in drive here, make and model, year, gearbox is now driving. So but the concepts can be extended to realistic situations. So you can for example do it for a computer game or real world applications or so on, which you will learn in next lectures. Think of a class as a set of instructions for how to make an instance. So the car class is a set of instructions that tells Python how to make individual instances representing specific cars. So let's make an instance representing a specific car here. So under the here we will use without indentation here. We will use my BMW here and car here. Of course, BMW is car. And here we will add here. Actually, you can use Ctrl and P here. CTRL here and P to see the information or the functions you can provide. But here we are also seeing this, which is we need to provide the make and model. Actually, let me here in the first step we need to provide make and model, year and gearbox. Here this is the same. So as you learned in previous lecture, we don't need to provide self as a parameter, so we will ignore it here. Make, first we are putting make and model, year and gearbox. So in make and model we will write a string, of course. So BMW 325 E here, and year is gonna be 2002, and the gearbox is gonna be automatic. So that's it. And after that we will print the instance, of which you here you will learn all of these codes, what these codes do and why are they doing this. So my cars make and model is here, and here we're my BMW dot make and model, and here print again format my cars car years of production, year of production is the my BMW dot year, is it right? We have make and model, we have year. Yes, we got an actually, let's try this. Yes, we got an error here. Car object is now attribute year. So first we are entering BMW 310. Actually, instead we need to here. My BMW dot year. We have drive, stop driving. We have make and model. Of course, we need to make it like this. Self dot. We forgot this here. Self year here. Self gearbox. Yeah, gearbox is gearbox. That's it. And here we will get here, and as you can see, is gearbox and year is appeared here. So first we're gonna print year. Let's run this here, and after that we will also print the gearbox type. Print my cars gearbox type is, and here we will enter my BMW dot gearbox here. That's it. Now I will explain all of these codes, what these do, and here as you can see we have successful output here. So now we will explain all of this here. So the car class we are using here is the one we just wrote in the previous lecture. So here we tell Python to create a car whose name, my car here, my BMW here, whose car make and model is BMW 325e, and the car year of production is 2002, and car gearbox is automatic. So when Python reads this line, it calls the init method in our car class with arguments, the make and model, year, and gearbox. In this case is, as I said, BMW 325e 2002, and automatic as gearbox here. And now then the init method create instances representing this particular car and sets the name, sets the make and model, year, and other attributes using the values we provided. So we assign that instance to the variable my BMW. The naming convention is helpful here, so we can usually assume that capitalized names like cars refer to class, and lowercase like my BMW refers to a single instance created from a class. To access the attributes of an instance, you use dot notation. So we access the value of my BMW's attribute using dot by writing BMW year or BMW make and model, BMW gearbox. So we use dot to access the value of my BMW's attributes named make and model, year, gearbox. So this is the instance and this is the attributes. So dot notation is used often in Python. So this syntax demonstrates how Python finds an attribute's value. So here Python looks at the instance my car and then finds the attribute make and model with my BMW, right? So this is the same attribute referred as the self, make, and model in the class car. So we use the same approach to work with the attribute year or gearbox. So the output here looks exactly like this. Firstly, my car's make and model is BMW, so we use my BMW dot attribute make and model. We use my BMW dot year, my BMW dot gearbox. So we can also call methods. So after we create an instance from the class car, we can use dot notation to call any method defined in car. So let's make our car to drive or stop driving, right? So after this, after print methods, or you can also add there or there as well. So if you add here my BMW, here we not defined my BMW, so you add to as the syntax, you need to use this variable after the variable created. So here my BMW is not created, that's why we are getting an error. So after BMW created, we can add, for example, my BMW dot drive, and here as you can see here we got nothing. So no, actually here the BMW 325e 2002 automatic is not driving, and after that we are printing a car make and model. So sorry, let's delete it. And after printing the specifications and information about our car, we can call the drive and stop driving methods, right? So my BMW dot drive, my BMW dot stop driving, my BMW dot drive, and my BMW dot stop driving. And actually what BMWs do good is drifting. So let's actually use add another method here, which is drifting. Start drifting here, drifting, and we use self here, and after that we will copy this. Actually let's, yeah, we will use print f here. So now we will use self dot make and model and self dot year. After that we will also add self gearbox is drifting here. Here let's add more d here. That's it. And after now we are driving now, and after that we're gonna start drifting. So start drifting, and as you can see here, BMW 325 2002 automatic is drifting here. So this syntax is quite useful when attributes and methods have been given appropriately descriptive names, like the start drifting, stop driving, and drive. So we can also create a multiple instances. So you can create as many instances from a class as you need. So let's create the second car here. Let's actually use the my Bugatti. No, it's too much. So let's my Honda here, Honda, and we will use my Honda equals here. So now we will again use the car, or actually we can also use the create a Honda here. It's here. So BMW, or it's Honda, right? So Honda Civic here, it's gonna be 2015. Let's actually use strings. We can also use integers, but yeah, string is more clear. So, and let's make it manual, right? More here. That's it. And here after that we can also use my Honda here, my Honda that, for example, we can also do this. Instead we can also change my BMW to my Honda, so we will get same result but different values. Honda and my Honda, and after that we can also my Honda that, let's make it drive. We can also drive Honda. We can do the same things that we did with BMW, like my Honda make my Honda drift, start drifting. That's it. We can also add Honda inside after the BMW, because Honda is defined here and we are adding our code here. Now let's run this, and here this is the output successfully. This is a lot of output, right? So this is the output here. So in this example we create a car named my Honda, and here each car here, my BMW and my Honda, is separate instance with its own set of attributes capable of the same set of functions. So here my car make and model is BMW 325e. For example, my car make and model is Honda Civic here, and my car's years of production is 2015, and my car's years of production is 2002. So this is how we work with the classes and their instances, and see you in the next lecture. Thank you for watching.